Hello there, and welcome to the Cosmographer. In 65 years of human spaceflight, fewer than 700 people have left the Earth, and hidden in their debriefs is a catalogue of things they could not explain. In 1962, the first American in orbit came home describing thousands of glowing lights that swarmed his capsule at every sunrise. In 1973, 3 astronauts watched a brilliant red light pace America's first space station for 10 minutes, photographed it 4 times, and the network that tracks every object in orbit said nothing was there. Behind the Moon, where no signal from Earth can reach, an Apollo crew listened to nearly an hour of whistling music in their headsets, and their own tapes preserve them debating whether to tell anyone at all. And China's first astronaut heard something knock, without pattern and without source, on the hull of his spacecraft, a sound the next 2 crews heard as well. Tonight, across 3 unhurried hours, we count down the 10 most disturbing things astronauts have seen in space, every case real, every entry carrying its honest label. And the one at number 1 is not outside any window. Nearly every astronaut has seen it, with their eyes closed. Get comfortable and settle in. If drifting off to the strange side of spaceflight sounds like your kind of night, a quick like and subscribe helps this channel reach more curious night owls like you. Because by the end of this countdown, you will know why the most disturbing sight in all of spaceflight appears only after the eyes are closed. Let's begin at number 10. Number 10. The Fireflies of Friendship. 7. Since the first human left the atmosphere in 1961, fewer than 700 people have flown in space. They are, as a group, the most carefully selected, most closely monitored, and most rigorously debriefed travelers in human history. Every heartbeat is recorded. Every word is logged. Every window is accounted for. And yet, across 65 years of spaceflight, a small and stubborn collection of reports has accumulated in the archives, accounts of things seen, heard, and felt that the people who experienced them could not explain at the time, and that, in a few cases, have never been explained at all. This video walks down 10 of those cases, ranked from number 10 to number 1. Every case on this list is real, which is worth saying plainly, because this subject attracts invention the way a porch light attracts moths. Each entry will carry its honest label. Some of these mysteries were solved within months. One took almost 40 years. One was never solved. One never happened at all, and the story of how it never happened may be the most instructive entry on the list. And the countdown has a shape. The early entries are things seen outside the glass particles, objects, lights, keeping pace. The middle entries move inside the hull, where the strangeness arrives by sound. And the final entries move somewhere far less comfortable, inside the observer. Because the most disturbing thing astronauts have seen in space is not out there among the stars. It is closer than the window. It is closer than the walls. And nearly every one of them has seen it, with their eyes closed. We will get there. But every countdown needs a place to begin, and this one begins in 1962, with the first American ever to watch a sunrise from orbit, and the swarm of glowing things that came up with the sun. On the morning of February 20th, 1962, an Atlas rocket stood on a pad at Cape Canaveral with a 40-year-old Marine Corps pilot named John Glenn folded into the capsule on top of it. The capsule was called Friendship 7, and it was small in a way that is difficult to appreciate today. The pressurized volume was about 1.5 cubic meters, roughly the interior of a telephone booth, and Glenn did not so much ride in it as wear it. The mission was called Mercury Atlas 6, and its assignment was simple to state and enormous to attempt. Put an American into orbit around the Earth keep him alive for 3 revolutions, and bring him home. The Soviet Union had already orbited Yuri Gagarin and then German Titov the year before, and the United States had managed only 2 15-minute suborbital hops. The pressure on this one flight, and on this one man, was continental. It is worth pausing on the machine he was trusting, because the trust was not obviously deserved. The Atlas was not designed as a passenger vehicle. It was an intercontinental ballistic missile, hastily domesticated, and its early record was a public embarrassment. Atlas rockets in that era failed often, and they failed photogenically, blooming into fireballs over the Cape while the astronauts who would one day ride them stood watching. Glenn and the other Mercury astronauts had personally witnessed such failures, and the joke inside the program, delivered with the gallows timing pilots perfect, was that they were about to sit on top of one and light it. The margins everywhere were thin. The capsule's walls were thin. The whole national effort was thin, improvised at speed against a rival that kept winning. What was being asked of Friendship 7, in plain terms, was this: accelerate a man to orbital velocity, about 17,500 miles per hour, a speed at which the fall of the capsule around the curve of the Earth exactly matches the curve itself, so that falling and flying become the same act. At that speed, you cross the continental United States in about 10 minutes. You cross the Atlantic in a quarter of an hour. No human being from the Western Hemisphere had ever moved at that speed, seen the world at that speed, or watched a sunrise arrive at that speed. And part of Glenn's assignment, written right into the flight plan, was simply to look out the window and report what being there was like. He was, formally and officially, the mission's own instrument. What his eyes recorded was data. Remember that, because it is about to matter enormously. The launch went well. Friendship 7 settled into an orbit that carried it around the entire planet in roughly 90 minutes, which is the detail that shapes everything else in this story. A 90-minute orbit means the sun rises and sets not once a day, but 16 times. 16 sunrises and 16 sunsets in every 24 hours, each compressed into a few seconds of extraordinary transition because there is no atmosphere ahead of the spacecraft to soften the light's arrival. Keep that number, 16 sunrises a day, somewhere comfortable in your mind. It will come back later in this list, wearing a darker meaning. Glenn crossed the Atlantic, crossed Africa, crossed the Indian Ocean in the dark. Over Australia, the city of Perth turned on its lights for him, every porch and window and street lamp, so that the first American in orbit would have something human to see in the darkness. And he saw it, a soft, glowing patch on the black continent, and thanked them. That is the kind of night it was. An entire planet, more or less, leaning toward one small window. And then, as Friendship 7 came up on its first orbital sunrise over the Pacific, something appeared outside the window. Understand first what an orbital sunrise itself is, because even without fireflies, it is among the most intense visual experiences a human being can have. On Earth, the atmosphere prepares you for the sun for the better part of an hour, brightening and warming by slow degrees. In orbit, there is no such courtesy. The spacecraft is flying at 5 miles every second, and the sun's approach is compressed into moments. First, a thin arc of the deepest blue appears along the edge of the world, the atmosphere seen edge on, a layer so shallow against the planet's bulk that astronauts routinely describe their shock at its thinness, the whole breathable world reduced to a rind of colored light. The blue builds, banded with orange and red, where the coming sun is already burning through the thickest air. And then the sun itself breaks the edge, not rising so much as detonating, full daytime brightness, arriving in seconds. 16 times a day, this. No astronaut has ever described being bored by it. Picture the moment as he lived it. The capsule is flying backward, the way Mercury capsules did, so Glenn is looking out along the path he has already traveled. The world below is black, the sky above is black, and the line between them is only beginning to declare itself, a thin band of deep blue building toward orange. The light comes up the way a match flares, quick and total. And in that first grazing light, the space around the capsule is full of particles. Thousands of them. They are small, they are luminous, and they are a pale, yellowish green, the color of certain summer insects. They drift past the window, slowly, at maybe 3 or 4 miles per hour relative to the capsule, unhurried, like snow that has forgotten how to fall. They stretch away from the spacecraft as far as Glenn can see, a field of soft lights extending into the distance in every direction. He is the first American ever to see an orbital sunrise, and he is seeing it through a cloud of something no briefing ever mentioned. His radio call from that moment survives, and it is worth hearing almost exactly as he said it. He reported that he was in a big mass of some very small particles that were brilliantly lit up as though they were luminescent. He said they looked like little stars. He said they went by the capsule like tiny specks floating past a slowly moving car. And then, reaching for the most honest comparison available to a man from small-town Ohio, he said they looked like fireflies on a summer night. The particles stayed with him for several minutes, thinning as the sun climbed and the light lost its shallow angle. When the capsule crossed back into daylight proper, they became invisible. And here is the detail that turned a curiosity into a genuine puzzle. They came back. On the second orbital sunrise, the Fireflies returned on schedule. On the third sunrise, the same. Whatever they were not a one-time event. They were a feature of the environment, appearing precisely at the boundary between night and day, 3 times in under 5 hours. On the ground, the reaction was not wonder. It was concern, and the concern had layers. The first layer was practical. Nobody knew what the immediate surroundings of an orbiting spacecraft looked like because no American had ever been there to look. If the vehicle was flying through some kind of particle field, Mission Control needed to know whether the particles could damage it. The second layer was less practical and more human, and it is the layer that gives this story its lasting bite. Among some of the medical staff, quietly, a different question took shape. Was the first American in orbit seeing things that were not there? Spaceflight medicine in 1962 was a discipline built almost entirely of predictions, and some of those predictions had been grim. There had been serious professional speculation that a human mind cut loose from the Earth might not hold. So when the man in the capsule reported swarms of glowing lights that no instrument registered and no theory anticipated, a portion of the flight surgeon community heard exactly what they had been braced to hear. The suggestion was never made to Glenn's face during the flight, but it existed, and he learned of it afterward, and by every account he resented it for years. He knew what he had seen. He had reported it carefully, in plain language, with estimates of size and speed and color. And the reward for that care was a whispered question about his mind. He flew the rest of the mission, dealt with a false warning light that suggested his heat shield might be loose, survived a re-entry that he had every reason to believe might kill him, and splashed down a national hero. The Fireflies came home with him as an open item. Through the spring of 1962, they remained exactly what they had been at sunrise over the Pacific, unexplained. There is a symmetry in who solved it that the space program itself seemed to savor. On the morning of Glenn's launch, as the Atlas lit beneath Friendship 7, it was Scott Carpenter, serving as backup and capsule communicator, whose voice sent the flight off with a phrase that entered the language. Godspeed, John Glenn. The man who blessed the voyage inherited its mystery. The answer arrived 3 months later, and it arrived by accident at the hands of the next man in line. On May 24, 1962, Scott Carpenter flew Aurora 7 on an almost identical 3-orbit mission. Carpenter knew about the Fireflies, of course. Every person in the program knew about the Fireflies. He was watching for them, and at his first orbital sunrise, there they were. The same slow, green-white drift Glenn had described. But Carpenter had an advantage Glenn never got: time to experiment and a spacecraft to experiment with. At one point in the flight, moving about the cabin, he happened to knock against the capsule wall. Outside the window, a fresh swarm of fireflies burst into view. He tried it again, deliberately this time, rapping on the hatch. More fireflies, on demand, streaming past the glass like sparks off a struck flint. That single gesture, a man knocking on a wall, solved the mystery. The particles were coming from the spacecraft itself. Friendship 7 and Aurora 7 were both shedding a slow blizzard of their own making, water vapor from the life support system venting overboard and freezing, exhaust products from the thrusters, condensation that had ridden up from the humid Florida morning, frozen onto the capsule's skin. In the cold of orbital night, the frost built up. Any motion, any vibration, any thump of a thruster or a knuckle shook a fresh crop of flakes loose, and they drifted alongside at nearly the capsule's own speed, which is why they seemed to float rather than fly past. For most of each orbit they were invisible, because a fleck of frost the size of a snowflake reflects almost nothing in the full glare of day and nothing at all in darkness. But at sunrise, for a few minutes, the geometry became perfect. The light arrived at a shallow, grazing angle, the way late afternoon sun catches dust in a quiet room, and every flake around the spacecraft lit up against the black like a lantern. The Fireflies were not a swarm the capsule had flown into. They were a halo the capsule had brought with it. The ship was molting, and at every sunrise, for a few minutes, it could see its own breath. The physics of why the flakes behaved so gently is worth a moment, because their gentleness was half of what made them uncanny. A particle shed from an orbiting spacecraft does not fall away or blow backward because there is no air to blow it, and it is already falling around the planet at the same 17,500 miles per hour as the vehicle that shed it. Released with only the faintest push, it enters an orbit almost identical to the capsule's own, and so it keeps pace, drifting alongside at walking speed, for minutes or hours, a companion by pure inheritance of motion. That is why Glenn's Fireflies ambled past like snowfall, instead of streaking past like meteors. They were fellow travelers, moving with him through the dark at 5 miles a second, their enormous shared speed invisible, only the tiny difference showing. And the sunrise timing, so suggestive of intention, was pure optics. Through orbital night, the flakes were unlit and invisible. Through full orbital day they were washed out, faint motes against glare. Only in the minutes of sunrise, with the light arriving low and grazing, and the sky behind them still black, did the geometry hand each flake a spotlight and a dark stage at the same time. They had been there all along, all night, every night. Sunrise was simply when the theater opened. The discovery also settled, permanently, a truth about spacecraft that every later mission would inherit, and that this list will need again before it ends. No vehicle in orbit is ever truly alone. Every spacecraft travels inside its own thin private weather, a drifting fog of frost flakes, paint chips, insulation fragments, wastewater crystals, and thruster residue, all of it pacing the vehicle in loose formation. All of it invisible until the light comes in at exactly the wrong angle, at which point any of it can light up, look enormous, and be honestly reported by a careful observer as an unexplained, glowing object. Hold that thought for later in this countdown, when a camera aboard a space shuttle points at a broken tether from 77 miles away, and the whole frame fills with pulsing disks. The Fireflies were the first lesson in a curriculum spaceflight has been teaching ever since. Out there, before you ask what something is, you must first ask how far away it is, and the second question usually has no answer. Carpenter, it should be said, paid a small price for his curiosity. He spent generously from his maneuvering fuel, turning the capsule to study the particles, and that spending contributed to a re-entry that went long. Aurora 7 splashed down some 250 miles past its intended point, and Carpenter spent hours in a life raft waiting for recovery aircraft, while a significant fraction of the United States briefly wondered whether he had died. The Fireflies were solved, but not for free. The story carries an epilogue across 36 years that is too good to leave out. In 1998, at the age of 77, John Glenn returned to space aboard the shuttle Discovery, becoming the oldest human being ever to fly there, a distinction he held for over 2 decades. The shuttle was a different universe from Friendship 7. Windows everywhere, room to float, companions, coffee. But the orbit was the same kind of orbit, and the sunrises came on the same 16-a-day schedule, and somewhere in that week, Glenn got to watch the light come up over the edge of the world again. This time, knowing exactly what every drifting spark outside the glass was, and exactly how long an honest answer can take to arrive. There is a small comic footnote to this story that the astronauts themselves enjoyed for decades, and since it is real, it belongs here. Some of the particles that accompanied later flights had an even less romantic origin than frost. When a spacecraft dumps wastewater overboard, it flash freezes into a spray of drifting ice crystals that catch the light beautifully. Wally Schirra, among others, referred to the resulting formation as the constellation Urian, and generations of crews have inherited the joke. Space, whatever else it is, has never been dignified for long. But step back from the comedy, because as the opening entry of this countdown, the Fireflies earn their place by establishing the pattern that every later entry will test. Look at the sequence. A trained observer in a machine, in an environment no human had ever occupied, sees something real. He describes it accurately and honestly. The description sounds impossible, and the honest report costs him something in this case, a whispered doubt about his sanity that followed him home. The mystery holds for months. And then the answer, when it finally comes, is found not by a committee or a theory, but by a man knocking on a wall. And the answer is mundane. And the answer is also stranger than the mystery in its own quiet way. You are never alone out there, because you travel inside a cloud of your own shedding, a slow snowfall of yourself, visible only at sunrise. The label on this first case, then, is the cleanest label on the list. Solved completely, within 3 months, to everyone's satisfaction, including Glenn's. Hold on to how that resolution felt, because you will not feel it often from here on. The Fireflies took one knock on one wall to explain. The next object on this list was seen for only a few seconds by one of the most qualified observers alive, and it has now gone more than 60 years without a name. The man who saw it spent the rest of his life calmly, insisting it was nothing special. The file spent the same decades refusing to close. We come to Gemini 4. Number 9. The object McDivitt could not name. In June of 1965, the United States flew its second crewed Gemini mission, Gemini 4, and almost everything about that flight became famous, except the thing this list is about. Gemini 4 was the mission on which Ed White opened a hatch, pushed himself out into the void on a golden umbilical, and became the first American to walk in space. The photographs of White drifting above the blue curve of the Earth, a small maneuvering gun in his hand, and pure joy visible through his visor, are among the most reproduced images of the 20th century. He famously called the order to come back inside the saddest moment of his life. That is the Gemini 4 everyone remembers. The Gemini 4 that concerns us happened on a quieter day of the same mission, when the hatches were closed, the spacewalk was over, and the command pilot was alone at the window while his crewmates slept. A word about the program itself, because Gemini has a habit of being skipped in the popular memory, sandwiched between Mercury's firsts and Apollo's moon, and it deserves better. Gemini was where the United States actually learned to fly in space. Mercury had proven a man could survive orbit. Apollo would need men who could change orbits, chase and catch other vehicles, dock with them, work outside, and endure for the length of a lunar voyage, and not one of those skills existed yet. Gemini, a two-seat spacecraft flown 10 times with crews across 1965 and 1966, built each of them from nothing, at a pace that is difficult to believe from this distance. Launches every few weeks, each mission deliberately harder than the last. Gemini 4's contribution to the curriculum was twofold: White's spacewalk and simple endurance. 4 days in orbit, at a time when the American record was 34 hours. 4 days, in a cabin smaller than the front seat of a compact car, 2 men in pressure suits shoulder to shoulder, with no computer worth the name and the window as the primary instrument. That is the vehicle, and that is the tempo of the era in which this sighting happened. The command pilot was James McDivitt, and his credentials matter to this story, so take a moment with them. McDivitt flew 145 combat missions in Korea. He graduated first in his class from the Air Force Test Pilot School. After Gemini, he would command Apollo 9, the first crewed flight of the lunar module, and after that, he would run the Apollo Spacecraft Program Office, meaning that the machines that landed on the moon crossed his desk for approval. It is difficult to construct, even hypothetically, a witness with better eyes or a cooler head. He was, in the vocabulary of aviation, a maximally sober observer. Here is what happened, in his own repeated telling across the decades. Gemini 4 was drifting. Early in the mission, an attempt to fly formation with the spent booster had consumed far more fuel than planned, one of Gemini's first hard lessons in how counterintuitive orbital chasing really is, and so for much of the remaining flight, the spacecraft simply coasted, thrusters quiet, tumbling slowly end over end to spread the sun's heat, husbanding what remained. The windows, therefore, did not point anywhere. They swept the sky in a slow rotation, serving up the Earth, the black, the sun, and the Earth again, in an endless, lazy cycle. It was during that drifting stretch, somewhere over the Pacific in the vicinity of Hawaii, that the moment came. Ed White was asleep, catching his scheduled rest in the seat inches away. McDivitt was awake, keeping watch, looking out through the small window as the slow tumble served up another arc of empty sky. And at some point, he became aware of an object out there, against the black. He described it the same way for the rest of his life. It looked like a white or silvery cylinder, and it had something sticking out of it, a projection he compared to an arm, or a pole, or an antenna. It appeared to be closing on the spacecraft, or at least changing its position against the window. He could not tell how big it was, and he could not tell how far away it was, and, as we will see, those two failures are actually one failure, and it is the most important fact in this entire case. McDivitt did what a test pilot does. First, he simply looked hard, the way gunnery training teaches, trying to pull structure out of the shape, attitude, aspect, motion against the stars. Then he reached for the cameras, of which the spacecraft carried two, a still camera and a movie camera, and began shooting through the window, dividing seconds he did not have between aiming a lens and keeping his eyes on the thing itself, the eternal witness's dilemma that has ruined more sightings than darkness ever has. He also began thinking, in a fully practical way, about whether he needed to maneuver because an object of unknown size on an unknown course near your spacecraft is not a philosophical problem, it is a traffic problem. And then the geometry betrayed him. The slow tumble of the capsule brought the sun across the glass. The window flooded with glare, and by the time the spacecraft rotated back to a usable viewing angle, the object was gone. The entire sighting had lasted seconds. He had gotten a look, and part of a photograph, and nothing else. He woke nobody, panicked at nothing, reported it through the proper channels, and flew the rest of his mission. What happened next splits into two stories, and the space between them is where this case has lived for 60 years. The first story is what the evidence did. The film came back and was developed, and it showed nothing usable, just glare and blur. Exactly what you would expect from a hand-aimed camera shooting through a small window in a rotating spacecraft in the seconds before sun blindness. Later, a photograph surfaced publicly that claimed to show the Gemini 4 object, a bright shape with trailing blobs of light, and it became one of the most reprinted UFO pictures in history. McDivitt himself examined it and said, flatly and repeatedly, that it was not what he saw. That famous picture, he explained, is sun glint reflecting off the layered glass of the spacecraft window, an artifact of the very glare that ended his sighting. Think about that for a moment, because the irony is almost perfect. The most famous piece of evidence in the case is a photograph of the thing that prevented there from being evidence. Meanwhile, the identification effort ran its course and came up empty in an instructive way. By 1965, the United States operated a tracking network of radars and cameras whose job was to maintain a running catalogue of every object in Earth orbit large enough to follow, a bookkeeping operation that continues, enormously enlarged, to this day. The catalogue then held hundreds of objects, live satellites, dead ones, spent rocket stages, and the loose hardware of 8 years of launches. In principle, any sighting from a spacecraft at a logged time could be compared against the catalogue to ask what was in the neighborhood. In practice, the comparison had soft edges everywhere. Orbits in the catalogue drifted between radar passes. The sighting's own time and direction were estimates made by a busy pilot without instruments pointed the right way. And an object need only be modestly small or modestly far from a radar's attention to exist in orbit without existing in the books at all. After the flight, the candidates were checked. The most commonly proposed match, a satellite called Pegasus 2, a large winged spacecraft built to measure micrometeoroid impacts, turned out to have been over 1,000 miles away at the time, far too distant to appear as anything at all through a capsule window. The other natural candidate was Gemini 4's own discarded booster, the spent upper stage of the Titan II rocket that had put them in orbit, which was known to be circling the Earth on a track near theirs. McDivitt considered that possibility seriously, and he never fully embraced it, for a simple reason. He had already seen the booster earlier in the flight, tumbling end over end at a known distance. and he knew what it looked like. The object at the window had not looked like that. So the formal result of the search was this: nothing in the catalogue matched. The object had no name. Now, the second story is what the culture did, and here the case stops being about an object and starts being about a man. Because McDivitt spent the next 50 years, in interviews, in letters, at conferences, patiently saying the same thing, and the same thing was remarkably boring. He never said he saw a spacecraft from another world. He said the opposite, in the most literal language available. His position, held without variation from 1965 until his death in 2022, was that he saw something unidentified, where unidentified means exactly and only that he could not identify it. He believed it was almost certainly a piece of human hardware, an unmanned satellite or a fragment of debris, seen briefly at a bad angle in bad light. He would sometimes add, with the dryness of a man who had answered the question 1,000 times, that during the flight he was unable to identify a great many things, including, at one point, through a fouled window, his own reflection. And none of it mattered. The story had left him. The tabloids and the documentaries and eventually the internet needed the Gemini 4 astronaut who saw a UFO, and so that is who, in the public imagination, he became. The sighting took seconds. The correction took the rest of his life, and did not work. It is worth lingering on what those decades were like from inside them, because the McDivitt case is the cleanest specimen we have of a pattern that will shadow the rest of this list, the witness losing custody of his own sighting. McDivitt gave interviews. He answered letters, thousands of them over the years, many from school children, many from true believers who wrote to him as a kind of reluctant prophet. He appeared at panels where the question was always waiting for him at the end, and he answered it the same way every time, in the level tones of a man reading a checklist. I saw something I could not identify. I think it was a piece of hardware. I do not believe it was anything more. The famous photograph is not mine, and shows a reflection. He said it in the 60s and the 70s, and he was still saying it, patient and slightly weary, in the interviews of his final years. He died in 2022 at 93, one of the most accomplished aviators of his century, commander of the mission that first flew the machine that landed on the moon. And in the algorithmic afterlife, where old footage circulates forever, he remains, above all else, the astronaut who saw the UFO. The lesson is not about him. It is about the asymmetry. A sighting takes seconds, an explanation takes paragraphs, and a story that flatters the mystery will always travel lighter than the man dragging the footnotes behind it. So what did he see? The honest answer is that no one knows, and the honest follow-up is that the answer is probably dull. And the reason we cannot get from probably to certainly is a problem worth sitting with, because it governs half the cases on this list. On Earth, when you look at an object in the sky, your brain performs an unconscious triangulation using a lifetime of references: haze, clouds, the horizon, familiar objects of known size. In orbit, every one of those references is gone. There is no haze, so a distant object is exactly as crisp as a near one. There is no horizon behind it, only black. There is nothing of known size anywhere in the frame. What remains is a geometry problem with no solution. A small object nearby and an enormous object far away paint precisely the same image on a human retina and on a camera sensor. A bolt tumbling 30 meters from your window and a cylindrical rocket stage tumbling 30 miles away can look, for a few glare-shortened seconds, identical. The failure mode is not exotic, and it is not confined to orbit. It is a standing hazard of any sky. Airline pilots, among the most sky-literate observers alive, have on documented occasions taken evasive action to avoid collision with the planet Venus, a light source roughly 25 million miles beyond their windshield, because a bright point with no context reads as near and closing. If that misjudgment is available at cruising altitude, with a horizon and an atmosphere helping, consider the same brain at work in orbit with every aid removed. Astronauts are trained to know this, which is why the good ones, and McDivitt was among the best, refused to tell you how big something was or how far away it sat. He would only ever describe the image. White, cylindrical, something sticking out. The image is all he ever claimed to own. And that is the label for number 9. Unresolved and almost certainly mundane, and permanently stuck in the gap between those two words. It sits one notch above the Fireflies on this countdown, precisely because of that gap. Glenn's mystery had an ending, a knock on a wall that turned strangeness back into physics. McDivitt's mystery just stops, like a sentence interrupted, a few seconds of cylinder and then glare, forever. No resolution ever arrived to discharge the small static voltage the story carries, and so it carries it still. But if a few seconds of unidentified object troubles the sleep of the archives, consider what the next case does to them. 8 years after Gemini 4 splashed down, America launched its first space station. And one September evening, the 3 men aboard it looked out and found a light keeping them company. It was red. It was brighter than any planet has a right to be, and it did not leave for 10 minutes. They did what McDivitt never got the chance to do. They studied it, they discussed it, and they photographed it 4 times. It did not help. We come to Skylab. Number 8. The red light that followed Skylab. Skylab was America's first space station, and it is one of the great underappreciated machines of the space age. It was built from the converted upper stage of a Saturn V moon rocket, which meant it was enormous, about the internal volume of a small 3-bedroom house, launched in one piece in May of 1973. After a decade of capsules the size of telephone booths and sports cars, astronauts could now float across open rooms, run on a track around its circumference, and lose each other. 3 crews lived aboard it, each staying longer than the last, learning for the first time what happens to a human body and a human mind that stays in orbit not for days, but for months. Skylab also nearly died at birth, and the story of its wound matters to this entry, so hold on to it. 63 seconds into the launch, aerodynamic forces tore away the station's meteoroid shield, a thin cylindrical skin meant to protect the hull and manage its temperature, and the debris took one of the 2 main solar wings with it and jammed the other closed. What reached orbit was a crippled house, overheating in the sun, starved of power, trailing torn metal. The first crew's mission was transformed on the ground, in days, into a rescue. They deployed a folding sunshade, a parasol pushed out through a small airlock, and freed the stuck solar wing during a spacewalk with cable cutters at the end of a pole, and the station lived. The rescue is remembered as one of the finest repair jobs in the history of engineering. What is remembered less often is its residue. Skylab's launch and repair had shed an unknown quantity of debris, torn shielding, fasteners, fragments, some of it inevitably left on orbits not far from the station's own. A house that has exploded a little, on its way to being a home, leaves pieces of itself in the neighborhood. Remember that when the light appears. The second crew arrived in July of 1973, and their names deserve saying. Alan Bean, the commander, had already walked on the moon as part of Apollo 12, and would later leave the astronaut corps to spend the rest of his life painting what he had seen there. Owen Garriott was a scientist, an electrical engineer with a doctorate from Stanford, one of the first of the new breed, flown for their minds rather than their stick-and-rudder hands. Jack Lausmer was a marine aviator and the crew's designated workhorse. Together they flew what was then the longest spaceflight in history, 59 days, orbiting the planet more than 800 times, and their mission became famous mostly for how much science it produced and how well three very different men got along in a metal house that never stopped falling. Life aboard, by September, had settled into the deep rhythm of a working expedition. The crew ran medical experiments on themselves, photographed the Earth on a schedule, and operated the station's crown jewel, a solar observatory that studied the sun above the atmosphere for the first time at such length, returning tens of thousands of images of flares and the corona. They exercised. They grew accustomed to the strange luxury of floating through rooms, and they looked out the window in their scarce free minutes, because the window is what every astronaut ever debriefed says they miss most. The point is that by day 60-ish of occupancy, these were not jumpy men in a new machine. They were residents, deeply familiar with their sky, with what the station shed, with what sunlight did at every angle. They knew the ordinary strangeness of their environment, the way a farmer knows his fields at dusk, which is what makes the evening in question worth an entry on this list. The part of their mission that concerns this list occupies roughly 10 minutes of those 59 days. On September 20th, 1973, as Skylab was approaching one of its 16 daily sunsets, the crew noticed a light out the window. Not a flash, not a drifting flake, not a firefly. A steady, brilliant light holding its position in their sky, and it was red. Not the faint red of a distant star, but vividly, unmistakably red, and bright by their description, brighter than any planet, brighter than Venus appears from Earth, which for a point of light in the sky is a very high bar. It appeared to be at a similar altitude to the station, on a similar orbit, keeping pace with them the way another ship keeps pace on a parallel course. It did not flare and fade like a tumbling object catching the sun. It simply rode there, off in their sky, red and constant. The timing of the sighting, near sunset, matters twice over, so take the geometry slowly. A station 400 kilometers up sees the sun for a while after the ground below has gone dark, and an object at or above the station's altitude stays sunlit longer still. There is a deepening band of evening in which the world below is in night. The sky is black, and high things alone still burn with direct light. It is the hour when ground observers see satellites best, bright sparks crossing a darkened sky, and it is also the hour when the light itself grows strange, because sunlight arriving at such an object has skimmed the edge of the atmosphere on its way, shedding its blues to scattering and arriving stained toward orange and red. Anything metallic riding that light can glow like a coal. The crew knew all of this, the way sailors know tides. That is precisely why the object stopped them. It was not that a light existed in the sunset band, but that this light was too bright, too red, and too steady, and matched nothing they had seen in 2 months of those sunsets. The crew did exactly what you would want a crew of professionals to do. They watched it. They called each other to the window and confirmed that all three of them saw the same thing in the same place, which matters enormously because it removed at a stroke the whole family of explanations that live inside a single human eye. They estimated its behavior against the stars. And Jack Lausmer took photographs, 4 frames that still exist in the archive. They tracked the light for about 10 minutes as the station flew on toward the shadow line. Then Skylab crossed into orbital night. The geometry of sunlight that had been illuminating whatever it was changed completely, and the red light was gone. It was never seen again. Not by them, not by the third crew, not by anyone. Back on the ground, the sighting entered the machinery that exists for exactly this purpose. And here is where the case earns its place on this list. Because there was a way to check. By 1973, the North American Aerospace Defense Command maintained a catalogue of every object in Earth orbit large enough to track by radar, thousands of entries, from live satellites down to spent rocket stages and drifting debris. A bright object pacing Skylab at a known time on a known orbit should have been in that catalogue. The check was made, and the answer that came back was the one answer nobody wanted. Nothing. No catalogued object matched the position and behavior of what the crew had seen. The most closely watched volume of space in existence, monitored by the most sophisticated tracking network ever built, had been visited by a 10-minute red light that the network said was not there. The photographs did not rescue the situation. When the 4 frames were examined, they showed what photographs of distant point sources through spacecraft windows almost always show. A small, red blob, slightly structured, consistent with a bright light source, somewhat out of focus, and utterly insufficient to identify anything. A blob does not have a shape you can measure or markings you can read. The pictures proved the light existed, which was never in doubt given 3 witnesses, and proved nothing else at all. So what was it? The candidate explanations are worth walking through slowly, because their incompleteness is the actual substance of this entry. The first candidate is debris from Skylab's own mission, some piece of hardware shed during the station's famously violent launch, during which a meteoroid shield tore away or discarded during its repair. An object released from a spacecraft tends to stay on a similar orbit for a long time, drifting slowly ahead or behind, which fits the red light's station-keeping behavior well. The second candidate explains the color. An object seen near orbital sunset is lit by sunlight that has skimmed the top of Earth's atmosphere on its way there, and light that grazes the atmosphere is reddened by the same physics that reddens every sunset you have ever watched. A perfectly ordinary aluminum object in that geometry can glow like an ember. Put those 2 together and you have a respectable story. A piece of the station's own history, pacing it in the reddened light of the shadow line, disappearing the instant the light was withdrawn. The third candidate is simpler still, that something in the catalogue was wrong that day, a tracked object whose recorded position had drifted from its true one, so the match existed, but the bookkeeping missed it. Every one of those stories is plausible. None of them was ever confirmed. And confirmation, note, was never really possible after the fact, for reasons built into orbital mechanics itself. An object in low Earth orbit is not permanent. The faint drag of the atmosphere's outermost fringe steals energy from it continuously, and small, light objects fall out of the sky within months or years, burning on re-entry, leaving no wreckage, no serial number, no second chance at an answer. Whatever shared the sky with Skylab that September evening almost certainly ended as a brief, anonymous meteor over some empty stretch of ocean within a few seasons, its identity converted permanently into a question. There was no way then, and there is no way now, to reach back into 1973 and attach a name to 10 minutes of red light. The window for solving the case was the case, and it closed when the station crossed into shadow. That is the uncomfortable resting state of the Skylab sighting. It has 3 good endings and possesses none of them. And notice what this case has that the previous 2 did not. Glenn had a single witness and got his answer in 3 months. McDivitt had a single witness, a few seconds, and no usable film. The Skylab 3 sighting had 3 witnesses, all of them separately excellent. 10 full minutes of observation, 4 photographs, and a formal check against the complete inventory of objects in orbit. It is, by the standards of this genre, the best documented sighting a crewed American mission has ever produced. And the documentation purchased nothing. The file is simply open, and has been open for more than 50 years, and there is no longer any realistic prospect of closing it, because whatever paced the station that evening has long since decayed from orbit or drifted beyond any hope of association. The case's afterlife followed the pattern this list has established, though gentler than most. It was aired publicly, not as a leak, but in the ordinary way, mentioned in debriefs and documentation, and the UFO literature adopted it eagerly, for understandable reasons. It is that rarest of specimens, a multiple witness sighting from a scientific crew with photographs and an official negative tracking result, and it requires no embellishment whatsoever to be strange. To their lasting credit, the retellings have mostly kept it intact because there is nothing to improve. The true version is already the best version. It appears in serious catalogues of astronaut observations alongside Glenn's Fireflies and McDivitt's cylinder, always with the same closing line, "No identification was ever made," which happens to be exactly true. The crew, for their part, treated it the way professionals treat an anomaly. It went into the debriefs, it was discussed without drama, and they went back to work because they had a solar telescope to run and a record to set. Alan Bean spent his later decades being asked about many things, the moon mostly, and the red light never seemed to weigh on him. Perhaps that is the right note for this entry. Label it honestly. Unidentified, probably mundane, formally unresolved, and observed by people who refused to let it become larger than the 10 minutes it occupied. The system built to know everything in orbit came back empty exactly once for these 3 men, and they had the discipline to leave it at that. It is natural to wonder whether such a case could stay open today, and the honest answer is probably not, which sharpens rather than softens the old file. The modern tracking catalogue follows tens of thousands of objects, down to fragments a few inches across, with radar fences and telescopes updating orbits continuously. The International Space Station carries cameras beyond a 1970s astronaut's dreaming, and a 10-minute co-orbiting light would today be triangulated, catalogued, and named before the crew finished describing it. The Skylab sighting is, in that sense, a fossil of a particular era, the narrow window when humans lived in orbit long enough to notice things, but the bookkeeping of the sky was still coarse enough to lose them. The window closed. The case it left behind did not. You may notice a pattern assembling across these first 3 cases. A real observation, made in good faith, degraded by glare or distance or darkness into a permanent question mark. Each case so far has involved a handful of witnesses and, at most, a few frames of film. The next case breaks that pattern completely. It was recorded on video, in motion, for minutes at a time, by a camera aboard the space shuttle, and then broadcast, and the footage shows not one unidentified object, but dozens of them at once, drifting and pulsing around a piece of NASA hardware the size of a small city. It is probably the strangest-looking sequence of images the agency has ever released, and this time we know exactly what it shows. That is what makes it interesting. We come to the broken tether. Number 7. The swarm around the broken tether. In February of 1996, the Space Shuttle Columbia went to orbit, carrying one of the most ambitious physics experiments ever flown, and the experiment's failure produced a piece of video that people are still arguing about 30 years later. The mission was STS-75, and its crew of 7 was a small United Nations of spaceflight. Among them, Franklin Chang Diaz, the Costa Rican-born physicist, who would go on to tie the record for most spaceflights in history. Claude Nicollier of Switzerland, Umberto Guidoni of Italy, and Jeffrey Hoffman, a veteran astronomer-astronaut who had helped repair the Hubble Space Telescope. Their primary cargo was called the Tethered Satellite System, and the idea behind it was almost absurdly elegant. The satellite itself was a gleaming sphere about 5 feet across, built by the Italian Space Agency, packed with instruments to measure the electrical environment it would fly through. The mission was a joint American and Italian undertaking, years in preparation, and its Italian heritage is why 2 of the 7 crew members were Italian astronauts flying to shepherd their country's spacecraft. Here is the idea behind it. The Earth has a magnetic field. A wire moving through a magnetic field generates an electrical current that is not exotic physics. That is the principle inside every generator and every alternator on the planet. Now, scale it up. Take a satellite, about the size of a beach ball, weighing half a ton. Attach it to the shuttle by a conducting cord and reel it out. Not out by a few meters. Out by nearly 13 miles. The full tether was 12.8 miles of cable, thinner than a shoelace for most of its length, a copper conductor wrapped in insulation, unspooling upward from the shuttle's payload bay toward a satellite riding far overhead. Together, shuttle and satellite would become the 2 ends of the longest electrical circuit ever flown, sweeping through Earth's magnetic field at more than 17,000 miles per hour, and the physics said that circuit should generate thousands of volts. If it worked, it pointed at something remarkable. Future spacecraft might draw meaningful electrical power out of the empty-seeming space around a planet, paying for it only in orbital energy, electricity conjured from motion and magnetism, with no fuel burned at all. The deeper promise, the one that justified the enormous trouble, ran in both directions. Run the circuit one way, and the tether is a generator, converting a sliver of the shuttle's orbital energy into electrical power, potentially kilowatts of it, for as long as the wire flies. But push current through the tether the other way, from onboard power, and the same physics runs in reverse. The wire pushing against the planet's magnetic field becomes a motor, raising the orbit with no propellant at all. A working electrodynamic tether is, in effect, a way for a spacecraft to climb or descend by gripping the Earth's magnetic field directly. An engine with no fuel tank, and versions of the idea are still studied today for dragging dead satellites out of orbit at end of life. The 1990s experiments were the technology's great audition. That is what was riding, scientifically, on 12.8 miles of insulated copper. An earlier attempt in 1992 had jammed after deploying less than 1,000 feet, a heartbreaking 840 feet of a planned 12 miles, halted by a protruding bolt. This was the reflight, and for a while, it was glorious. On February 25th, the satellite rose smoothly away from Columbia, the tether paying out mile after mile, the voltage climbing just as predicted, the experiment producing exactly the current the equations promised. The crew watched the cable stretch away until the satellite at its end was a bright star, nearly 13 miles above them. They had reached 12.2 miles of the planned 12.8 when the tether broke. By that point, the experiment had already validated itself. The circuit was live and generating roughly 3,500 volts, driving current between the satellite and the shuttle exactly as the physics required, and the science teams were, by every account, elated. The tether had become the longest artificial structure ever deployed in space, a single human-made object nearly 13 miles from end to end, sweeping around the planet like the hand of an enormous clock. It did not break the way a rope breaks under load. and the failure investigation later established this with grim precision. The culprit was a flaw in the insulation, likely nothing more than damage from a speck of grit or a pinhole void in the coating. Through that microscopic gap, the Tether's own multi-thousand-volt charge found a path to the surrounding plasma, and an electrical arc ignited. The arc burned through the cable, like a torch through thread. Aboard Columbia, the crew watched the severed tether recoil away from them, and there is video of this moment. 12 miles of cable and its half-ton satellite springing upward and away, released into a higher orbit, abruptly nobody's experiment anymore. Gone. If the story ended there, it would be a footnote in the history of space engineering. What put it on this list happened 3 days later. Columbia's orbit and the derelict Tether's orbit continued to evolve separately, and the shuttle eventually came within visual range again, roughly 77 nautical miles from the drifting cable. The crew pointed a camera at it, partly for documentation and partly because a team on the ground wanted observations. The camera they used was sensitive beyond the range of the human eye, into the ultraviolet, designed to see faint, high-energy phenomena. And what came down on the video link, broadcast live on NASA's public television feed, was this. The tether appears as a long, glowing, slightly curved line hanging in the black, luminous along its whole length, like a filament from some enormous lamp. And around it, the frame is alive. Dozens of pale, translucent, disc-shaped objects drift through the shot. They pulse gently as they move, brightening and dimming with a rhythm that looks for all the world like the swimming contractions of jellyfish. Several of the discs appear to have a notch cut into one edge, as though someone had taken a neat bite out of each one. They move on lazy, independent paths, at different speeds, in different directions. And, most alarming of all, some of them appear to pass behind the tether. Hold that geometry in your mind. The tether is 12 miles long. If a disk passed behind it, the disk is at least as far away as the tether, and for it to appear that large at that distance, it would have to be miles across. The public feed carried all of it, and the sequence escaped into the culture almost immediately. This was the era when enthusiasts ran video recorders against NASA's television channel around the clock, precisely in the hope of catching such moments. And the tether footage was captured, duplicated, and circulating within days, later to be replayed frame by frame in slow motion in 100 documentaries, the pulsing of the discs lovingly zoomed and annotated. Slow motion, it is worth noting, was half the trick. Slowed down, drifting debris acquires deliberation, and deliberation reads as intent. Watched at natural speed, the scene is a snow flurry. Watched at 1/4 speed with ominous narration, it is a fleet holding formation. It has been called the best UFO footage ever recorded, and if you judge purely on atmosphere, the title is deserved. It is genuinely uncanny to watch, even now, even knowing everything you are about to know. Because here is what the video actually shows, piece by piece, and the explanation deserves to be walked through as slowly as the mystery, since the explanation is where the real lesson lives. Start with the disks themselves. A space shuttle in orbit is never alone. Like Glenn's capsule 34 years earlier, it travels inside its own faint cloud of shed material, flakes of ice from water dumps, particles from thruster firings, fragments of insulation, all of it drifting slowly near the vehicle, and all of it brilliantly lit whenever the sun is at the right angle. Every one of those particles is tiny, and every one of them is close, some just a few feet from the lens. And the camera was focused on a target 77 nautical miles away. A small, bright object drifting near a lens that is focused at effective infinity does not appear on the video as a small, sharp dot. It appears as a large, soft-edged, translucent circle, an out-of-focus blur that photographers call bokeh. The size of the disk on screen has nothing to do with the size of the object. It is a portrait of the camera's optics, not of the thing itself. A fleck of ice the size of a grain of rice, 3 feet from the lens, renders as a ghostly circle that looks the size of a building. The gentle pulsing, so suggestive of something alive, is the flicker of an irregular particle tumbling in sunlight, its brightness changing as it rotates, smeared into softness by the defocus. Now the notch, the detail that convinces so many viewers because it repeats. Disc after disc carries the same little bite mark, and identical structure across many objects surely means a fleet of identical craft. In fact, it means precisely the opposite. When a point of light is rendered out of focus, the blurred circle it produces takes on the shape of the camera's aperture, the opening formed by the iris mechanism inside the lens. If that opening is not a perfect circle, if the blades of the iris leave a small irregularity, then every out-of-focus light in the image inherits exactly the same irregularity. The notch is not on the objects. The notch is inside the camera. Its perfect repetition across dozens of discs is not the signature of a manufactured fleet. It is the signature of a single lens through which all of them were photographed. Identical flaws across many objects point to one shared cause, and the only thing all those drifting particles shared was the camera. Which leaves the killer detail, the discs that pass behind the 12-mile tether. Here, the explanation is the most elegant of the three. The tether on that video is not a thin line of metal. It is an overexposed light source. Fully sunlit, seen against black space by a sensitive camera, it blooms, its brightness bleeding outward on the sensor, so that it renders far wider and far more luminous than the physical cable. When one of the dim, translucent, out-of-focus particle disks drifts across that blazing stripe, the faint disk does not register against the glare. The bright pixels simply win. The disk fades out as it enters the bloom and fades back in as it exits the other side. And the eye, watching that sequence, reaches the obvious and completely wrong conclusion. It went behind. It did not go behind. It went in front and was outshone. The illusion is so clean that once you know it, you can watch the disks dim slightly as they approach the tether's glow, exactly as a foreground object being washed out should, and exactly as a distant object being occluded should not. And here is the satisfying part, the part that separates this explanation from mere assertion. Every element of it is reproducible, tonight, by anyone, with ordinary equipment. Take a camera, focus it on a distant streetlight, and let dust or snowflakes drift near the lens. Each speck renders as a large translucent disk, pulsing as it tumbles through the light. If your lens's aperture has any irregularity, every disk will carry the same notch in the same place. Point the camera past a bright, bare bulb and watch faint nearby motes vanish as they cross its glare and reappear on the far side, apparently passing behind a light source they are actually in front of. Independent analysts, including career spaceflight engineers who have written about the tether footage at length, have staged exactly these demonstrations, recreating every celebrated feature of the video on a tabletop. The tape requires nothing that is not already inside a camera and a cloud of dust. What it required from the audience was only the assumption that video in orbit works the way video works on Earth, and that assumption, as this whole countdown keeps discovering, is the most reliably broken instrument in space. So the full accounting reads like this. Enormous pulsing disks, small nearby debris, defocused. Identical notches, the camera's iris, stamped on every blur. Passing behind a 12-mile structure. Glare washout, an artifact of dynamic range. Every single element that made the footage famous dissolves under analysis, and NASA's explanation, given at the time and elaborated by independent analysts since, has never needed revision. The crew themselves were never mystified. Astronauts see shuttle shed debris on every flight and know its choreography intimately. Jeffrey Hoffman and his crewmates watched the same tape as the public and saw ice and dust in bad focus, because they had spent their careers learning what cameras do in orbit. And that is why this entry, fully explained, still ranks above 2 unresolved cases on this countdown. Because the Tether footage is the single best demonstration ever broadcast of a truth that governs every case on this list. In space, cameras do not behave the way your lifetime of watching Earth-based footage has taught you to expect. There is no focus reference, no size reference, no distance reference, and dynamic range beyond anything a sensor can hold. Orbital video does not merely fail to resolve mysteries. It manufactures them reliably from dust and optics, and it will hand you living jellyfish and mile-wide disks at 77 miles if you let it. An audience of millions looked at that tape and saw a swarm of enormous organisms. 7 astronauts looked at the same tape and saw the inside of a lens. The distance between those 2 readings is not a distance of intelligence. It is a distance of experience, with an environment where seeing cannot be trusted to mean what it has always meant. There is a coda to the mission worth keeping because it restores the story to its rightful owners. The Tether experiment, for all its heartbreak, succeeded scientifically. The 5 hours of live circuit before the break returned data that validated the physics and fed Tether research for decades. And the failure investigation's finding that a defect smaller than a grain of sand can defeat 12 miles of engineering became one of those expensive lessons aerospace tuition keeps charging. The crew flew home to full careers. The satellite and its 12 miles of cable circled the Earth as the strangest object in the sky for a few weeks, visible to ground observers as a drifting line of light, and then re-entered and burned. Nothing about the episode required a swarm. What it required and received was 7 professionals, a broken wire, and a camera that told the truth in a language almost nobody watching had learned to read. The label here, then, explained thoroughly and satisfyingly, with the explanation more instructive than the mystery ever was. And notice, as we set it down, that every case so far, solved or not, has been a thing seen. Light through a window, light on a sensor. The countdown now leaves the window entirely. Because in May of 1969, 2 months before the first moon landing, 3 men flew around the far side of the moon, into the only place human beings have ever traveled where the Earth cannot be seen and no signal from home can reach, and in that perfect isolation, in headsets connected to nothing but each other, they heard something. We come to the music behind the moon. Number 6. The music behind the moon. To understand this entry, you first have to understand what the far side of the moon meant in 1969, and mostly still means today. It is not the dark side. It receives exactly as much sunlight as the side we see. What it never receives is Earth. The moon is tidally locked, keeping one face turned permanently toward us, which means there is a hemisphere of the moon from which our planet is never visible, not once, not ever, in 4.5 billion years. And because radio travels in straight lines, that hemisphere is also the one place a crewed spacecraft can go, where communication with Earth becomes not difficult, but physically impossible. 2,000 miles of solid rock stand between you and every transmitter on the planet. Mission Control cannot call you. You cannot call them. Every Apollo crew that orbited the moon experienced this as a scheduled, rehearsed event called loss of signal, a final crackle from Houston, then 40-some minutes of complete radio silence as the spacecraft swung around the far side, alone in a way that no traveler before or since the Apollo program has ever been alone. The nearest other humans were 250,000 miles away, and for those minutes there was no thread connecting you to them at all. The ritual of it deserves a moment, because the crews all described the same emotional grain. Houston would count them down to the interruption, the capsule communicator's voice reciting the seconds until the moon's edge severed the link, and there was always a small formality to the last exchange, a "see you on the other side" quality, spoken lightly, and meant completely. Then the carrier tone died, and the static changed character, and the crew was off the leash of the Earth for the first time in their lives. Some of them, in memoirs, confessed to loving it. The far side was the only office in the program where the phone could not ring. Others noted the opposite feeling, the small animal awareness that if anything went wrong in those minutes, the first Houston would hear of it was the silence continuing past its appointed end. Every far side pass was a held breath, 250,000 miles long, 40 minutes wide, 16 times a day for a lunar mission's duration. Consider what it would take to surprise 3 men inside that ritual. Then let the whistling begin. In May of 1969, Apollo 10 flew to the moon as the full-dress rehearsal for the landing. Its crew were 3 of the most experienced pilots alive: Thomas Stafford, John Young, and Eugene Cernan. Between them, they would eventually accumulate a resume unmatched in spaceflight. Stafford, the steady Oklahoman commander, on his 3rd flight. Young, who would go on to walk on the moon, command the first space shuttle mission, and fly in space across 4 decades. Cernan, who would return on Apollo 17 and become, to date, the last human being to stand on the lunar surface. Their mission was to do everything Apollo 11 would do 2 months later except touch down, and they did it, flying the lunar module, call sign Snoopy, down to within about 9 miles of the surface, while the command module, Charlie Brown, held orbit above, close enough that the mountains of the moon rose visibly against their windows as they skimmed the landing zones, photographing and mapping the approaches Armstrong would fly in July. The Peanuts call signs were a gift to the press, and the crew played their humor broadly. But no one mistook the stakes. Everything about the landing had to be proven now, by them, or the July attempt could not go. It was a mission of firsts flown by men so seasoned that almost nothing could surprise them. Almost. At one point during the mission, with the 2 spacecraft flying separately, the crew crossed behind the moon into loss of signal. Picture the cabin in that stretch. The windows are full of the far side rolling past below, crater on crater, a landscape no eye ever saw before the space age. The radio link to Earth is dead by geometry, and the crew knows the schedule to the second. The only voices in the universe, as far as their headsets are concerned, belong to the 3 of them. And then, into that silence, a sound arrives. It begins as a whistling. Not static, not the familiar hiss of an empty channel, but a tone, and the tone moves. It slides up and down, warbling, wavering, rising and falling in slow curves, the way a musical saw sounds, or a theremin, the instrument that gave old science fiction films their voice. It is eerie, it is unmistakably present, and it does not stop. It goes on, fading and returning, for the better part of an hour. Picture the far side itself, rolling past beneath them while it played, because the landscape is part of the scene. The far side does not look like the moon you know. The familiar face, the one with the dark patches that cultures have read as rabbits and men for millennia, is smoothed by those patches, ancient lava plains that filled its greatest basins. The far side never got them. Its crust is thicker, and the lava mostly stayed below. What the crew saw out the window was the moon, with the makeup off, crater packed upon crater, without relief, a face of pure bombardment, 4.5 billion years of impacts recorded and never erased, lit starkly and shadowed absolutely, with no atmosphere to soften a single edge. It is a landscape no human eye evolved for, sliding past a few dozen miles below in total radio silence, scored, on this particular pass, by a thin electronic whistling that no one aboard could source. The men watching it were the least superstitious professionals their species produces. The tapes record how it landed on them anyway. We know exactly what the crew said next, because the spacecraft carried onboard recorders that captured cabin conversation even when no signal could reach Earth, and the tapes were transcribed. The transcript of that pass reads like a scene no screenwriter would dare submit. One of the crew asks the others, "You hear that? That whistling sound?" And then, groping for a description, he lands on the phrase that would follow this story forever. It sounds like, outer space type music. Another agrees. They remark on how strange it is. They wonder aloud, in real time, on tape, behind the moon, what it could possibly be. The whistling carries on, indifferent to them, and they fly on inside it, listening. Sit with the sound itself before we come to what they said about it, because the crew's descriptions repay attention. A whistle that wavers is not neutral content for a human ear. Our species is wired to find agency in modulated tone. A flat hiss is weather, but a pitch that moves, swells, and returns is a voice until proven otherwise, which is why the theremin was scoring alien invasion films 2 decades before Apollo. Its gliding wail, chosen precisely because it sits in the uncanny territory between instrument and speech. What rose in those headsets behind the moon was, acoustically, that exact object. An unstable singing tone, arriving on the one channel that should have carried nothing at all, in the one place where nothing could. The crew's phrase, outer space-type music, is usually quoted for its charm. Listen to it again as evidence. 3 test pilots, groping for a category, reached past every mechanical option straight to music, because that is what the sound most resembled. Something composed, something performed, something intended. And then, the transcript records something even more interesting than the sound. As the pass continues, the crew begins to discuss not the phenomenon, but the reporting of the phenomenon. "Shall we tell them about it?" one asks them, meaning Houston, meaning the debriefers, meaning the world on the other side of the rock. And the conversation that follows is hesitant. They are not sure. They talk about whether anyone would believe them. 3 men whose word was trusted with $100 billion program and each other's lives, and their honest first instinct, confronted with an hour of impossible music, is to weigh whether saying so out loud will cost them. "Nobody will believe us," runs the sentiment on the tape, and it hangs there, recorded, unanswerable. To understand the weight of that hesitation, remember the world these men came from. Test pilot culture ran on a currency of credibility that could be spent exactly once. The community's institutional memory included careers quietly ended by the wrong entry in a medical file, and every astronaut knew the Fireflies story, knew that even John Glenn, with a nation watching, had come home to whispered questions about his perceptions. An anomaly report was never free. Weighed against that, their hesitation stops looking like timidity and starts looking like arithmetic. The sound was strange. The sound was probably nothing, and the cost of being the crew that heard music behind the moon was unknowable. What tips the scene from interesting to quietly moving is that they said all of this out loud to each other on a recorder they knew was running. The tape preserves not just the sound, but the deliberation, the actual minutes of three men pricing honesty. Keep that sentence. Nobody will believe us. Like the 16 sunrises, it will return later in this countdown, worn by different people. And it will be heavier the second time. They did report it, as it happens, quietly, through proper channels, and the world took no notice for 4 decades, because the tapes and transcripts simply sat in the archive, unclassified in any dramatic sense, but unread, the way millions of pages of the Apollo program sat unread. This is a point worth pressing, because the later mythology would need the word classified the way a fire needs oxygen. The onboard recordings were mission data, handled like all mission data, transcribed by the agency, in this case in the early 1970s, and filed. Nothing was sealed by frightened officials. Nothing was suppressed. The archive of Apollo is simply oceanic, tens of thousands of hours of audio and millions of pages, and the overwhelming majority of it has been read by no one since the day it was filed, not because it is forbidden, but because it is enormous and mostly concerns valve settings. In 2008, the material was made broadly public, and eventually a television documentary found the Far Side Passage and put the phrase outer space-type music in front of a global audience, and the story detonated, as it was always going to. Headlines asked what NASA had been hiding for 40 years. The truthful answer, nothing in particular, was, as usual, less contagious than the question. Cernan himself, by then in his 70s, stepped in to deflate it personally, telling interviewers he had never given the sound a second thought, that it had obviously been the radios. It did him no more good than patience had done McDivitt. The music, once loose, belonged to the audience. So what was the music? The answer had been sitting in plain sight for decades, and the best witness for it is the loneliest man in the history of exploration. 2 months after Apollo 10, Michael Collins flew Apollo 11's command module alone, while Armstrong and Aldrin walked on the moon below. Each time he swung behind the far side, Collins became a category of alone that has been calculated with some relish. One human being, sealed from his species by a planet's width of vacuum on one side and 2,000 miles of rock on the other. And in his memoir, Collins describes hearing it too. An eerie sound, he wrote, a woo-woo in his headset, strange enough that it would have lifted the hair on his neck, except for one thing. The radio technicians had already briefed him. He knew it was coming, and he knew what it was, because after Apollo 10's report, someone had done the unglamorous engineering work of finding out. The explanation is this. The command module and the lunar module each carried VHF radios for talking to one another, entirely separate from the big dish antennas that talk to Earth. When both spacecraft had their VHF systems powered on in proximity, the two transmitters interfered. Radio interference between two nearby transmitters produces heterodyne effects, beat frequencies, the electronic equivalent of two guitar strings slightly out of tune, creating a slow, pulsing wah between them. Fed into a headset, those beats become audible tones that slide and warble as the geometry and the electronics drift, whistles that rise and fall in long curves, music-like precisely because beat frequencies are, in the most literal sense, the raw material of music. The sound only occurred when both vehicles' radios were up. It followed the hardware configuration with perfect obedience, on Apollo 10, on Apollo 11, on the missions after. It had nothing to do with the moon at all, except that behind the moon was the only place quiet enough, in every sense, for anyone to pay attention to it. The spacecraft had been singing to each other the whole time. The far side is simply where the crews could finally hear it. As a mystery, then, this case is closed, and was closed almost before it opened. But notice what the closure does not touch. Everything the tapes preserve remains exactly as strange as it was. The explanation tells you what made the sound. It does not unmake the scene. 3 men in a small cabin, in the one place in the universe where no human signal can reach, listening to their own machines sing and deciding, on the record, whether the truth was affordable. The far side of the moon in 1969 was the most isolated acoustic environment any human being has ever occupied. Sound cannot travel in a vacuum. Outside that hull, there was not silence in the way a quiet room is silent. There was the total absence of the possibility of sound, forever, in every direction, for 250,000 miles. The only sounds in existence, locally speaking, were the ones inside that cabin. 3 sets of lungs, the hum of the fans, and an unexplained whistling that had chosen that moment to begin. The bravest thing on the tape is not anyone's composure. It is the fact that they kept talking about it, kept describing it to one another, kept it in language, which is what humans do with the uncanny to keep it a manageable size. There is one more turn of the screw worth giving. The far side music was radio interference, certainly. But the moon does have a genuine relationship with radio silence that makes the far side special in a way the explanation only deepens. Because no transmission from Earth can reach it, the far side is the quietest radio environment in the inner solar system, shielded by 2,000 miles of rock from the entire electromagnetic roar of human civilization. Every broadcast tower, every radar, every phone, every one of the billions of devices that have turned our planet, in radio terms, into a permanent scream. Radio astronomers dream about the far side for exactly this reason. A telescope there would listen to the universe through the only perfect silence within reach, able to hear faint cosmic signals, including the long wavelength whisper of the universe's first dark ages that can be heard from nowhere on or near the Earth. Serious proposals for such observatories now exist in several space agencies, and the first robotic landers have already begun working that territory. In 2019, a Chinese spacecraft made the first landing in history on the far side, communicating with home by relay satellite, since no direct signal can cross the rock. The place where 3 astronauts heard impossible music is, by physics, the best listening post our species will ever have. Whatever faint signals the cosmos is actually sending, the far side of the moon is where they will be easiest to hear, in a silence so complete that in 1969, 2 radios whispering to each other across a few miles of vacuum sounded like a song. The label for number 6, solved, absolutely, with the solution confirmed by the next man through the door, and the strangeness somehow fully intact anyway. Some mysteries are like that. The answer satisfies the mind and leaves the scene alone. And there is a thread hanging from this story that recorded worry, nobody will believe us, 3 of the most credible men alive rehearsing disbelief they never fully received. They were lucky. Their strange report was explained within months by colleagues who took them seriously. The next entry on this countdown is about the people who were not lucky. It concerns a class of witnesses, hundreds of them, over 6 decades, who reported enormous lights standing in the sky above the world's thunderstorms, and who were, more or less politely, told by the entire scientific establishment that they had seen nothing at all. They had not seen nothing. They had seen something real, something colossal, and it took until 1989 and one accidentally pointed camera to prove that every one of them had been telling the truth. We come to the lightning that strikes upward. Number 5. The lightning that strikes upward. For most of the 20th century, there was a category of pilot report that went straight into the drawer where aviation kept its embarrassments. The reports came from cargo pilots over the tropics, from military crews at high altitude, from airline captains threading between storm systems at night, and they described, with remarkable consistency, the same impossible thing: light above the thunderstorms. Not reflections, not distant strikes seen through cloud, but enormous structured flashes standing in the clear air high over the storm tops, where the textbooks said nothing existed but thin, calm stratosphere. Some described towering red glows, there and gone in an instant. Some described fountains of blue light climbing out of the anvils of great storms like water from a burst main. The reports shared 3 qualities. The witnesses were experienced professionals. The descriptions agreed with one another across decades and continents, and the phenomenon they described could not exist. The paper trail reaches back further than aviation itself. Scattered 19th century accounts describe upward flashes above storms seen from mountaintops and ships, filed then under atmospheric curiosities and forgotten. By the mid-20th century, the sightings had accumulated enough to acquire informal names, passed between flight crews like folklore, rocket lightning, upward lightning, the flames. What they never acquired was standing. A report with no photograph, describing a millisecond event seen at night from a moving aircraft by a single observer, is the weakest currency in science, no matter how many times it is independently minted. Everyone knew what lightning was and where it lived. It went from cloud to ground, or from cloud to cloud, down in the weather where it belonged. The air above a storm was an electrical dead zone. And so, for 60 years, the reports were received the way institutions receive impossible testimony from reliable people, which is to say, kindly, and then not at all. Pilots learned to stop mentioning it. More than one has said in later interviews that you did not report such things twice because the flight surgeon's office was not a place a career wanted to visit. An entire class of eyewitness simply went quiet. Nobody will believe us, the Apollo 10 crew had murmured behind the moon, and they were wrong. And it worked out. The pilots knew nobody would believe them, and they were right, and it cost the science 60 years. The great irony, unearthed by historians of the field once there was a field to have historians, is that theory had quietly predicted the phenomenon all along, and then forgotten its own prediction. In the 1920s, the Scottish physicist Charles Thomson Rees-Wilson, the Nobel laureate who invented the cloud chamber, worked out that the electrical field above a large thunderstorm should, at sufficient altitude, exceed what the thin, high air could withstand, and that the sky above great storms should therefore break down and discharge, up there, in the dark. He published the idea. It sat in the literature for almost 70 years, uncontradicted and unpursued, while the pilots who kept seeing exactly what Wilson had predicted were told it could not happen. The prediction and the eyewitnesses spent 7 decades in the same building, never introduced. Vindication, when it finally came, was an accident, and it is one of the tidiest accidents in the history of atmospheric science. On the night of July 6, 1989, a team at the University of Minnesota, led by a veteran space physicist named John Winkler, was testing a low-light television camera, equipment intended for an upcoming rocket study. The test was mundane. Point the camera at the night sky, record, verify the sensitivity. The camera happened to be aimed toward the northern horizon, where, a long way off, a large thunderstorm was working. When the team reviewed the tape, 2 frames stopped them. In those frames, Above the distant storm stood two brilliant columns of light, rising into what should have been empty sky. The columns were not lightning, as any textbook drew it. They stood far too high, reaching toward the edge of space, and they had structure, form, verticality. Winkler had spent a career studying the physics of the upper atmosphere, and he understood immediately what he was holding. Hard, repeatable, photographic evidence of the thing pilots had been describing since before the Second World War. 2 frames of videotape, exposed by accident, ended 60 years of institutional deafness in about 1/30th of a second. What followed the Minnesota frames is a small model of how science accelerates once permission is granted. Within a few years, dedicated campaigns were flying. Aircraft with low-light cameras circling above the great storm alleys of the American plains, catching sprites by the dozen in a single night, and confirming, among other things, their color, that deep red the pilots had always claimed and the skeptics had always doubted. Observers learned the trick of it, that sprites above a distant storm can be caught even from the ground, even occasionally by a dark-adapted naked eye, if you watch the black space above a far-off storm rather than the storm itself. Today, sprite photography is a thriving amateur pursuit. Hobbyists with ordinary cameras and patience produce images from their backyards that would have secured a mid-century career, and airline passengers occasionally catch one through a cabin window without knowing what they have. The phenomenon that was still officially impossible in 1988 became, within one generation, a weekend hobby. Once scientists knew the phenomenon was real, and once cameras of sufficient speed were pointed deliberately, discoveries came in a flood, and the family of what are now called transient luminous events turned out to be larger and stranger than any pilot's report had dared. The first and most famous members are the red sprites, and the name is honest. They are red, and they are elusive, and they are enormous. A sprite is a discharge that erupts in the mesosphere, the thin air between roughly 30 and 55 miles up, directly above a powerful thunderstorm. It lasts a few thousandths of a second, almost never longer, which is why the naked eye so rarely catches one, and why 60 years of witnesses could never bring home proof. But in those milliseconds, a sprite can stand 30 miles tall. Its shapes repeat across events with an odd biological insistence. Some look like colossal jellyfish, a glowing red canopy trailing tendrils. Some look like carrots, or columns, or groves of luminous kelp. A single sprite can occupy more volume of sky than the entire thunderstorm that spawned it. The mechanism, worked out over the 1990s, connects it to a special class of lightning below. When an unusually powerful positive stroke transfers a great load of charge from cloud to ground, it leaves the electrical field high above the storm, momentarily unbalanced, and the thin air up there, needing far less persuasion to glow than the dense air below, breaks down. The result is a discharge of almost hallucinatory scale, born and dead, between 2 beats of a human heart. Even the color is information. The red is the glow of nitrogen, the same gas that fills 4/5 of every breath you take, fluorescing under the discharge in air 100,000 times thinner than the air at the ground. A sprite is, in the most literal sense, the upper sky itself lighting up, the atmosphere's own substance made briefly visible, the way a neon sign is just the gas inside it, shown its own electricity. The sprites turned out to have relatives. Blue jets are cones of deep blue light that launch directly from the tops of the most violent storm cells and climb to 25 or 30 miles, lasting long enough, a few tenths of a second, that a fortunate observer can genuinely watch one ascend. Gigantic jets, the rarest of the family, do something that would have ended careers to describe in 1960. They connect a thunderstorm top directly to the ionosphere, the electrified layer at the edge of space, 55 miles and more above the ground. In a single continuous discharge, a lightning bolt from the weather to the doorstep of orbit. The first were documented in the early 2000s, and they remain prizes. Only a scattering are recorded each year, mostly over tropical oceans, and each one transfers to the upper atmosphere an electrical charge comparable to the mightiest conventional strokes below. An observer, positioned well on a mountaintop or an aircraft or a passing spacecraft, sees a tree of blue-white light grow out of a storm top and keep growing, second after impossible second, until its crown touches the airglow. It is the closest thing the atmosphere does to reaching up and touching space on purpose. And the strangest siblings of all are the elves, a strained acronym the field has learned to live with, which are not bolts at all but rings, perfectly circular waves of dim red light that bloom at the base of the ionosphere and expand to 300 miles across in under 1,000th of a second, the visible footprint of a lightning stroke's radio pulse slapping the upper atmosphere from below. 300 miles, in less than a millisecond, drawn on the ceiling of the sky. And the light, it turned out, was only the visible fraction of the storm's upward violence. In 1994, a spacecraft built to watch for gamma rays from exploding stars, the most energetic light in nature, caught flashes of gamma radiation coming from the wrong direction. Not from the sky above, but from the earth below. The sources were thunderstorms. These terrestrial gamma-ray flashes, as they are now called, are produced when a storm's electrical fields accelerate electrons to nearly the speed of light inside the cloud, and they are bright enough that instruments built for dying stars register them from orbit. Later, observatories added a stranger detail still. Some storms launch brief upward sprays of antimatter, positrons created in those same electron avalanches, a fountain of annihilating particles rising from an August afternoon's weather. None of this endangers anyone on the ground, and none of it was suspected while your grandparents were alive. It is simply what thunderstorms have always been doing overhead, flickering at the edge of space in gamma rays and antimatter, while below, people watched the downward strokes and believed they were seeing the whole show. And this is where the story earns its place on this particular list, because the finest seats for this show have always been above it. The space shuttle was among the first deliberate observers. In the early 1990s, payload bay cameras recording storms below caught sprites from orbit, and those recordings helped drag the field into respectability. But it is the International Space Station that turned the top of the atmosphere into a laboratory. In September of 2015, the Danish astronaut Andreas Mogensen spent part of his brief mission at the station's cupola windows running an experiment called Thor, named for the appropriate god. The assignment sounds simple, and was not. Ground forecasters identified the most electrically violent storm systems on the planet in real time. The station's orbit was checked against them, and Mogensen, with a few minutes' notice, floated to the cupola with the camera to catch a passing storm top at the correct oblique angle, hand aiming at weather 300 miles away, moving past at 5 miles a second. On the pass that mattered, the target was a monster storm system over the Bay of Bengal. What he recorded exceeded the experiment's hopes. The video shows blue discharges flickering and dancing across the storm top, kilometer-scale blue flashes going off like depth charges in the cloud deck, and among them a pulsing blue jet climbing toward space. It was among the clearest footage of these phenomena ever captured, and it was taken by a human being looking down at weather from above, watching a storm fire upward at him. Since April of 2018, the job has been permanent. An instrument suite called ASIM, the Atmosphere Space Interactions Monitor, rides mounted on the outside of the station's European Columbus module, watching the Earth's storms full-time, with cameras and photometers built for exactly this quarry. ASIM has caught blue jets erupting from storm cells over the Pacific, including a celebrated sequence near the island of Nauru, has mapped elves rippling outward across the airglow, and has recorded flashes and gamma-ray bursts born inside thunderclouds that make it plain the upper reaches of ordinary weather are electrically wilder than anyone taught a generation of pilots to believe. Astronauts, meanwhile, see the storms whole in a way no one else ever has. From 400 kilometers up, on a night pass, a large storm system is not a grey ceiling, but a living map. Continents of cloud strobing from within, dozens of strikes per second across a single system, lightning propagating along cloud channels in branching rivers of light hundreds of miles long. Crews describe watching storms talk to each other, one flash triggering cascades across a whole weather front. And every so often, above that familiar violence, the other thing appears. A red ghost standing over the storm for an instant, gone before the eye fully commits to it, the sprite seen not from below through a lucky gap in the weather, but from beside, at altitude, at eye level. There are astronaut photographs of sprites now, red filaments hanging in the black margin between the glowing atmosphere and space, most of them caught by accident in long-exposure sequences shot for other purposes, discovered later by researchers combing the frames, because even from the best seat in existence, a subject that lives for 1,000th of a second is nearly impossible to hunt on purpose. Crews describe the frustration fondly. You watch the storm, you know the sprites are firing, the cameras run, and your own eyes, blinking at precisely the wrong moments, miss a dozen for every one they catch, a red something at the edge of vision, gone before the glance completes. From orbit, the disturbing geometry of it is inescapable in a way no textbook diagram conveys. The Earth storms are not only hammering the ground below, they are firing upward, at the sky, toward the camera, toward you. Honest label for number 5, confirmed, completely. One of the great vindications in modern Earth science, with the microphysics still being written. Sprites are now photographed by hobbyists from their backyards, by airline passengers with phone cameras, by the station overhead every week of the year. Which leaves the disturbing part of this entry nowhere near the mesosphere. The disturbing part is arithmetic. The atmosphere was doing this all along, above every large storm on Earth, thousands of times a night, planet-wide. A permanent upward fireworks display of 30-mile discharges throughout the entire history of the human sciences, and we proved it in 1989 by accident, with a camera pointed the right way for the wrong reason. 60 years of qualified witnesses were filed and forgotten, not because the evidence contradicted them, but because the theory did, and the theory was mistaken about the sky it claimed to describe. It is worth carrying that one forward, gently, as this countdown descends into stranger territory. Being right too early is, from the inside, indistinguishable from being wrong. A sprite, at least, has somewhere to be. It lives and dies in 1,000th of a second, 30 miles of light, and it never returns to trouble the same witness twice. The next entry on this list did the opposite. It came back. It came back again and again, mission after mission, year after year, to spacecraft after spacecraft of the same design. And it chose the loneliest audiences imaginable, crews of 1, 2, and 3 sealed in orbit, far from help. It did not glow, and it could not be photographed, because it was not a light at all. It was a sound. It was something knocking on the hull. We come to Shenzhou 5. Number 4. The knocking on Shenzhou 5. On the morning of October 15th, 2003, A Long March rocket lifted off from the Jiuquan Launch Center at the edge of the Gobi Desert, and when it cleared the tower, China became the third nation in history capable of putting a human being into orbit with its own hands. The human being in question was a 38-year-old fighter pilot named Yang Liwei, and it is difficult to overstate how much weight sat on that one man. He had been selected from among the best pilots of a nation of 1.3 billion people. He was flying a spacecraft, Shenzhou 5, on its first crewed mission ever, atop a rocket whose crewed reliability was, until that morning, a matter of engineering projection rather than history. 2 nations had done this before him, but that was little comfort where he sat. Their experience was not transferable. Their mistakes had been paid for in their own languages. Every Chinese citizen who had ever lived and looked at the night sky was, in a sense, standing behind him. He would fly alone, 14 orbits, 21 hours and 23 minutes, and then come home in a capsule to the grasslands of Inner Mongolia. That was the plan. And remarkably, that is almost exactly what happened. Shenzhou 5 flew beautifully, with one exception that Yang did not speak about publicly for years, and which belongs in this portrait of the man before we come to the knocking. During ascent, as the rocket burned through a particular altitude band, the vehicle developed a low-frequency vibration, a resonance around 8 cycles per second that happened to couple with the natural frequencies of human internal organs. For roughly 26 seconds, by his own later account, Yang endured an oscillation that felt as though it was shaking him apart from the inside. Pain past anything the centrifuge had taught him, severe enough that he genuinely believed, for part of it, that he was about to die within the first minutes of his nation's first crewed flight. He could not speak. He watched the seconds pass. Then the rocket burned through the band, the resonance faded, and he went back to work. Ground controllers, watching him, unblinking, on the cabin camera, are said to have feared the worst until they saw his eyes move. He reported the vibration in exacting detail after the flight, and the rocket was modified so that no later crew has experienced it. Keep that story in mind as this entry unfolds, because it tells you precisely what kind of witness this is. A man who, having been shaken to the edge of consciousness by his own launch vehicle, described the experience so carefully that the problem was found and engineered away. When a man like that tells you he heard knocking, the interesting question is never whether he heard it. The mission entered the history books as a nearly flawless debut. It took 13 years for the world to learn that something aboard that flight had genuinely unsettled its pilot. And it was not the rocket, not the re-entry, not the loneliness. It was a sound. Why the 13-year delay before the world heard about it? Nothing sinister. The account simply followed the rhythm of its country's spaceflight culture. Yang returned from orbit, a national figure of the first magnitude, was promoted into the leadership of the astronaut program, and spent the following decade largely inside its discipline, where crews discuss flights in debriefs rather than talk shows. As China's program matured, and its veterans began giving retrospective interviews and publishing memoirs, the stories of the early flights surfaced the way Apollo's had surfaced decades before, in the recollections of men finally at liberty to be storytellers. The knocking emerged in that thaw, offered by Yang himself, unprompted, as one of the vivid details of a flight he was at last describing at length. Yang described it publicly in those interviews, given around 2016, long after the flight, with the care of a man who has thought about his words for over a decade. Somewhere in the middle of the mission, in the quiet cruise between the great events of launch and return, he heard a knock. His description is uncommonly precise, and it is the precision that has made it famous. It sounded, he said, like someone striking the body of the spacecraft the way you would knock a wooden hammer against an iron bucket. Not a ping, not a creak, not the electronic chirp of a system doing its work. A knock. Percussive, resonant, and, most disquieting of all, ambiguous in the one dimension that mattered. It seemed to come, in his words, neither from inside the spacecraft nor from outside it exactly. It simply arrived in the structure, as though the hull itself had been struck. Linger on his chosen image for a moment, because it is doing precise work. A wooden hammer on an iron bucket specifies everything an engineer would want. The striker, soft rather than metallic, so no sharp clang. The struck object, hollow and resonant, so the sound rings briefly in a body of air. The blow, moderate, deliberate, single. It is the sound of something being tested, the way you might wrap a barrel to judge how full it is. Yang was not reaching for menace. He was reaching, like Glenn with his Fireflies and the Apollo 10 crew with their music, for the most exact homely comparison available. And exactness is what makes his account impossible to wave away. Stay inside that cabin for a moment, present tense, because this is the scene the whole countdown has been descending toward. The spacecraft is crossing the night side. The cabin is dim, the instrument lights steady, the ventilation fans providing the only sound, a low, constant breath of machinery. Yang floats loosely in his couch. Restraints, mid-task, a checklist in one hand. Below the porthole, the dark Pacific slides past, and the knock comes. One knock. Clean, resonant, percussive, the voice of struck metal, from everywhere and nowhere in the structure at once. The checklist stops. The fans go on breathing. He holds still, listening the way you have listened in a house at 3 a.m, his own heartbeat now audible to him, and the silence stretches, 30 seconds, a minute, refusing to repeat itself or explain itself. He unclips, pushes gently off the couch, and drifts to the porthole, and the glass gives him the answers it always gives. The hull's curve, faintly starlit, the black, the turning earth. Nothing. He hangs there anyway, watching his own reflection watch him, one man and an unexplained sound, sharing the only pressurized room within thousands of miles in any direction. Consider his situation with some care, because the situation is the substance of this entry. Yang Liwei was, at that moment, the only Chinese national in space, and the only human being within thousands of miles in any direction, including straight down. He was sealed inside the only pressurized volume available to his species in his corner of the sky, a cabin the size of a small car's interior, wrapped in vacuum. There was no possibility, none, of anything being outside to knock. He knew this. Every hour of his training agreed on this. And the knock came anyway. It did not repeat on a rhythm, which would have suggested machinery. It came irregularly, without pattern, sometimes a single knock, sometimes a small series, then long stretches of nothing. It arrived during day passes and night passes alike. It could not be predicted, and it could not be summoned. When he braced for it, silence. When he had half forgotten it, knock. What Yang did next is exactly what this list has come to expect from its best witnesses, and it deserves recording. He did not call the ground in alarm. He investigated. Each time the sound came, he unstrapped, moved to the porthole, and looked outside, scanning the hull edge and the black beyond it for anything, debris, a fitting, a visitor of any description. He saw, every time, nothing. The curve of the spacecraft, the turning Earth below, the stars. He examined the cabin around him for a loose item that might be drifting and tapping the wall. Nothing accounted for it. So he logged it, mentally filed it as unexplained, and went on flying his mission, because he had a nation on his shoulders and a landing to survive. The knock accompanied him, intermittently, through the remainder of the flight, an uninvited passenger with no mass, no face, and no explanation. Then he came home, and the story gains its second act, the one that elevates it above a mere curiosity. Yang debriefed the sound to the engineers, and, in his telling, they could not immediately reproduce or explain it. He described, in later interviews, spending time on the ground with technicians, listening to recordings and simulated sounds, trying to pick his knock out of a lineup, and never being fully satisfied that they had found it. And the sound, meanwhile, refused to remain a one-flight anomaly. 2 years later, in October 2005, Shenzhou 6 flew with 2 astronauts aboard, Fei Junlong and Ni Haisheng, on a 5-day mission. They heard it too. In 2008, the crew of Shenzhou 7, 3 men, among them Zhai Jigang, who performed China's first spacewalk on that flight, heard it as well. Same knock, same irregularity, same wooden hammer-on-iron bucket voice on 3 different spacecraft with 3 different crews across 5 years. Whatever was knocking was not a flaw in one vehicle. It was a property of the design, or of the environment, or of something subtler than either. Notice what the repetition across missions did to the case's logic, because it is the pivot on which the whole entry turns. A sound heard by one man, once, alone, lives forever in the territory of testimony. It can be respected, but never examined. A sound that returns for the next crew and the next on the same class of vehicle has crossed over. It is no longer an experience, it is a property. Properties have causes. Causes can be hunted, and the hunt can be handed from crew to crew and engineer to engineer until someone corners it. The knocking's recurrence is what saved it from becoming another Salyut-style legend, and the difference was not luck. It was the program's habit, inherited from every good flight test culture, of writing anomalies down and telling the next crew, which is the entire difference between folklore and engineering. Folklore repeats the fear. Engineering repeats the observation. Here the story produces the detail that, on a list full of eerie things, may be the single most quietly decent moment. Yang Liwei, having lived with the sound alone and unwarned, made sure that no one who followed him would have to. Before the Shenzhou 6 crew flew, he briefed them about the knock personally. "It is a normal phenomenon," he told them, in effect. "You will likely hear it. It has been heard before. It does not precede any failure. Do not let it frighten you." Think about what that briefing is. It is the first astronaut of a nation, unable to explain a sound, choosing to hand the next crew not the mystery, but the calm. Every haunted house story ever told ends with the family fleeing the house. Yang's version is the one where the first resident stays the full night, writes down what the house does, and leaves a note on the kitchen table for the next family, explaining which sounds mean nothing so that they can sleep. On a countdown of disturbing things, it is worth pausing on the fact that the most humane act in this entire video was performed in response to one of them. So what was knocking on Shenzhou? The explanation that has emerged, publicly offered by Chinese researchers and engineers around the same time Yang's account became widely known, is a beautiful piece of unglamorous physics, and it fits the facts with satisfying snugness. A spacecraft in orbit lives between 2 thermal and pressure regimes in constant slow negotiation. Inside, a maintained atmosphere, pressure held steady for the crew. Outside, hard vacuum and a temperature that swings brutally every orbit, roasting in direct sunlight, then plunging in the Earth's shadow 16 times a day. The spacecraft's structure, its inner wall panels in particular, sits between those regimes, and materials under changing pressure and temperature do not adjust silently. They flex. They accumulate strain and release it. A panel bowed by a pressure differential will, at some threshold, snap through to a new shape. And that snap, in a sealed metal vessel, sounds like nothing so much as a knock against the hull. You have heard this exact physics in miniature. A sealed plastic water bottle, carried from a warm room to a cold car, pops and ticks as its walls deform, on no schedule, sounding for all the world like something tapping it from outside. Scale that bottle up to a spacecraft, make its walls of metal and composite, wrap it in vacuum, cycle it through a 200-degree temperature swing every 90 minutes, and put one extremely attentive, extremely isolated human being inside it, and the wooden hammer finds its iron bucket. The irregularity fits. Strain releases when it releases, not on a clock. The recurrence across missions fits. Same design, same physics. The neither inside nor outside quality fits perfectly, because the sound was born in the one place that is both, the wall itself. There is a final piece of physics that explains the sound's most haunting property, the way it seemed to come from neither inside nor outside, and it is worth having because it will quietly demystify half the ghost stories you have ever heard. Human hearing locates a sound by comparing its arrival at the two ears, tiny differences in timing and loudness that the brain triangulates into a direction. That system evolved for sounds traveling through air from a definite place. But a sound born in a structure, in a wall, a hull, a beam, does not arrive through the air from one direction. It travels through the metal itself, radiating into the cabin from every surface more or less at once, and the brain's triangulation, fed identical answers from all directions, returns the only result it can. Everywhere, nowhere. Both. Submariners know this intimately. A hull popping under pressure change surrounds the crew rather than addressing them. Astronauts aboard the International Space Station live with a whole vocabulary of such sounds, pings and pops and groans as the structure crosses from sunlight to shadow, and mission veterans learn them as one learns the settling noises of an old house. Yang had no veterans to inherit that vocabulary from. He was the first man in a brand new house, hearing its first night noises, with no one in the world able to tell him which sounds meant nothing. That is the loneliness at the center of this entry, and it is also, precisely, the loneliness he spared everyone who came after. It must be said, in honesty, that this explanation, while widely accepted and almost certainly correct, was never elevated to the status of formal official finding with a designated test to close the file. The label for number 4 is therefore mostly explained with the small residue of uncertainty that attends any sound heard by one man, alone, a great distance from every other ear on Earth. Yang himself has carried it with grace. He has recounted the story with a slight smile in interviews, neither inflating it nor disowning it. The first spacefarer of his nation content to have brought home, along with everything else, one genuinely strange souvenir and the good sense not to be ruined by it. He never heard the sound again after his flight, he has said. On the ground, it never followed him. Of course, it did not. It was never his sound. It belonged to the ship. There is one more reason this entry sits where it sits, at the hinge of the countdown. Notice what has happened to the strangeness as we have descended. It began outside the glass, as far away as a swarm of particles or an unnamed cylinder. It has been moving inward ever since, to the radio in the headset, and now to the wall itself, the last physical boundary between the astronaut and the vacuum. The knock on Shenzhou 5 was real. and the wall was doing the knocking. From here on, the countdown crosses that wall. The remaining entries are no longer about the spacecraft at all. They are about the occupant. And the next one concerns the most famous thing any cosmonaut has ever been said to see in orbit. An event involving 7 enormous winged figures reported from a Soviet space station in 1984. It is the best-known story in the whole genre of space strangeness. It is in countless books and 1,000 documentaries. And as we will see, the most disturbing thing about it is that it almost certainly never happened, and it may outlive every true story on this list anyway. We come to the Angels of Salyut 7. Number 3. The Angels of Salyut 7. The story, as it is usually told, goes like this. It is July of 1984, and 3 Soviet cosmonauts, Leonid Kizim, Vladimir Solovyov, and Oleg Atkov, are 155 days into a mission aboard the Salyut 7 space station, on their way to setting a world endurance record. It is an ordinary working day in orbit. And then, the station is engulfed in light, a brilliant orange glow that floods the interior, pouring through the portholes, bright past all explanation. The crew move to the windows, and outside, keeping pace with the station, they see figures. 7 of them. They are enormous, the story specifies, tall as airliners, and they are shaped like human beings, but with wings the size of sails and faces the versions agree to call serene, wearing expressions of calm that the cosmonauts find more affecting than the wings. The figures fly alongside Salyut 7 for about 10 minutes, unhurried, luminous, regarding the station. Then they are gone, and the orange light goes with them. The story adds a second act. Some days later, the glow returns, and this time, 6 people see the figures, because the station has been joined by a visiting crew, including Svetlana Savitskaya, the second woman ever to fly in space. 6 trained Soviet flyers, the account concludes, all reporting the same 7 winged giants, all sworn to silence, the whole affair sealed away in classified Soviet files, where it remains. The cosmonauts, the story is careful to note, were found to be in perfect psychological health, which is offered as the final, chilling detail. They were not mad, therefore it was real. It is a magnificent story. It has structure, escalation, corroboration, and the irresistible perfume of the sealed archive. It also has, built into its foundations, a delicious historical irony that explains much of its spread. These were cosmonauts of the Soviet Union, officers of a state whose official philosophy held the heavens to be empty of everything but physics. Angels appearing to anyone would be a story. Angels appearing to the atheist state's finest, aboard the atheist state's flagship, carried the special voltage of a cosmic practical joke, and the versions told in the West rarely fail to underline it. The story was not merely spooky. It was, for a certain audience, satisfying, and satisfaction is the most powerful preservative a legend can have. It is also, almost beyond serious doubt, a fabrication, and this entry exists to take it apart honestly, piece by piece, and then to show you the genuinely disturbing thing underneath it, because there is one, and it is better than the angels. Begin with the sourcing, because every investigation begins with the paper. The mission is real. Kizim, Solovyov, and Atkov flew aboard Salyut 7 in 1984 and set their record, 237 days, a colossal achievement of endurance and medicine. Savitskaya's visiting flight is real too. On that mission she became the first woman to walk in space, an accomplishment that deserves to be more famous than any tabloid tale attached to her name. The station was real. The dates are real. The people are real, and were among the most accomplished flyers of their generation. What has never been real, in the sense of being traceable to any primary source, is the event. There is no mission log entry, no radio transcript, no debrief document, no memoir passage, no interview in which any of the 6 named crew members describe seeing figures of any kind outside Salyut 7. In the entire documentary record of a program that logged everything, obsessively, the angels appear nowhere. The story exists only in retellings, and the retellings, when you trace them backward through the decades, converge not on Moscow, but on the American supermarket checkout aisle. The earliest known print appearance of the Salyut 7 angels is in the mid-1980s tabloid press, the same genre of publication then reporting on Bigfoot's wedding and the return of Elvis. From there, the story migrated, as good stories do, into paranormal anthologies, then into the early internet, then into documentaries with ominous narration, acquiring at each step the barnacles of specificity, the exact day count, the wingspans, the serene expressions, the classified files that make a legend feel like a leak. The classified Soviet report, the story's load-bearing wall, has never been produced, cited, numbered, or named. It is not a suppressed document. It is a plot device. The retellings betray themselves in a second way, subtler and, once seen, unmistakable. They cannot agree with each other. In some versions, the mission day is 155. In others, it drifts. In some, the glow is orange. In others, golden or blinding. The figures are as tall as airliners, or taller. Their expressions serene or joyful or knowing. Some versions have the second sighting. Some do not. Some move it to a different crew entirely. This is not how documented events behave. A real incident, anchored to logs and transcripts, holds its details fixed no matter who recounts it, which is why every telling of the Apollo 10 music can quote the same words off the same tape. A legend, transmitted mouth to mouth and page to page with no anchor beneath it, mutates at every handoff, each teller unconsciously repairing and improving it. Folklorists use exactly this signature, stable core and drifting details, to identify a story that is alive in the folk sense, growing, adapting, and answerable to no source. The Angels of Salyut 7 fail the fixity test as badly as any story in the space canon. And notice the tell, the one detail that gives the game away most cleanly. The story insists the cosmonauts were evaluated and found psychologically sound, and presents this as proof that the sighting was objective. But that is not how any space program processes an anomalous report. It is how a storyteller inoculates a tale against its most obvious objection. Real anomaly reports, as this countdown has shown you 5 times already, generate paperwork, follow-up, engineering investigations, camera assignments, briefings to later crews. Fabricated ones generate reassurances that the witnesses were sane. The Salyut 7 angels come pre-packaged with their own rebuttal to skepticism, which is precisely what real events never bother to do. And the sharpest injustice of the legend is what it eclipses, because Salyut 7 does not need invented drama. The station is the setting of one of the most extraordinary true stories ever to happen in orbit. In February of 1985, while flying uncrewed between expeditions, Salyut 7 suffered an electrical cascade and died completely. No power, no communications, no attitude control, 100-ton building tumbling silently, its systems frozen, its interior dark. The Soviet Union chose to attempt what had never been attempted, a rendezvous with a dead, uncooperative, slowly rotating station. And in June of that year, Vladimir Janibekov and Viktor Savinik flew a Soyuz to it by eye, matched its rotation manually, docked with a corpse, and went inside wearing fur hats and winter gear, into rooms below freezing, walls furred with frost, water frozen solid in its lines. Working in shifts inside a dead building in orbit, they reconnected batteries, coaxed systems awake, one by one, and over weeks brought the station fully back to life. It is remembered in spaceflight circles as the greatest repair mission ever flown. It involved no angels, and every word of it is true, and the tabloid story about the same station is told 100 times for every telling this one gets. Keep that ratio in mind. It is the exact price of a good fabrication, paid by the truth it displaces. History even supplied a natural experiment that the story failed. When the Soviet Union ended, its space program's paper began to open. Memoirs poured out of the veterans. Historians gained access to design bureau records and mission documentation, and an entire generation of secrets, real ones, from fatal accidents long denied to lunar programs never admitted, came blinking into the light. It was the great declassification the legend had always gestured toward, and the angels were not in it. No document surfaced. No participant, freed from every Soviet-era constraint and often eager to publish, confirmed a word. Stories that were true and far more embarrassing to the old state emerged in detail. The 7 winged figures, which would have cost nothing to confirm, stayed exactly where they had always lived, in the retellings. Absence of evidence is famously weak proof, but a predicted archive opening on schedule and containing everything except the story is about as close as folklore ever comes to a controlled test. So the label on the story itself is legend. Not unresolved, not contested. Legend in the strict folklorist sense, a narrative that borrows real names and real dates to buy credibility it never earned. But now set the tabloid aside, because underneath the invention there is a real subject, and the legend survives precisely because it grows in genuine soil. The truth is that you do not need angels to find the outer edge of human perception in space. The environment will take you there on its own, and the space medicine literature has been mapping that territory carefully and without sensation for 60 years. Start with the body's chemistry. A space station is a sealed bottle in which the crew's own exhalations are the enemy. Carbon dioxide must be scrubbed from the air continuously, and scrubbing systems drift, clog, and fail by degrees. Elevated carbon dioxide produces headaches, confusion, and, at higher concentrations, hallucinations, and Soviet-era stations ran, by modern standards, warm and rich in exactly this respect. Add hypoxia, any shortfall of oxygen, whose classic onset symptoms include euphoria and visual apparitions, and which announces itself so gently that pilots are specifically trained to catch it in themselves before it blooms. Add sleep. A crew orbiting the Earth lives with 16 sunrises and 16 sunsets a day, a light schedule that shreds the circadian rhythm, and by day 155 of a record attempt mission, every human aboard is carrying a sleep debt no schedule can fully repay. Sleep deprivation, all by itself, in perfectly healthy people on the ground, reliably produces visual and auditory hallucinations after enough accumulated shortfall. Now stack all three: thin air, rich carbon dioxide, ruined sleep, inside an isolation more complete than any desert island, seasoned with genuine mortal stakes, for months. The remarkable finding of space medicine is not that minds under these conditions occasionally produce phantoms. It is that they do so as rarely as they do. The Earth-bound analogues make the point without any orbit at all. Crews, wintering over at Antarctic research stations, locked into months of darkness and the same dozen faces, have reported for decades a documented constellation of effects: fogged concentration, flattened mood, misheard voices, the sensed presence in an empty corridor, familiar enough that polar medicine studies it as a standard occupational syndrome. Volunteers in isolation chamber experiments, sealed in comfortable apartments with nothing wrong except the absence of sky and company, begin within weeks to report perceptual oddities. Submarine crews, cave expeditions, solo ocean rowers. Everywhere humans are sealed away with thin stimulation and thinner sleep. The mind begins, quietly, to furnish the emptiness. Orbit adds its own seasonings, the shredded day-night cycle chief among them, but the underlying dish is ancient and terrestrial. The brain abhors a vacuum far more reliably than nature does. And there is a specific phantom that extreme environments produce so reliably that it has a name, and it is worth knowing, because it is the respectable cousin of every angel story ever told. It is called the third man factor. In 1916, Ernest Shackleton and two companions crossed the glaciated interior of South Georgia Island, starving and frostbitten, at the end of one of the greatest survival journeys in history, and each man privately experienced the unshakable sense that a fourth person was traveling with them, just at the edge of the group. Present, benevolent, and silent, none of the three mentioning it until the crossing was done. And each learned the others had felt it too. The detail so moved the poet T.S. Eliot that he set it into the wasteland a few years later, the figure who walks always beside you, counted and uncountable, giving the phenomenon a permanent place in literature before science had a name for it. None of them mentioned it until afterward, when they discovered they had all felt it. The same presence has since been reported by solo sailors, high-altitude mountaineers, polar trekkers, shipwreck survivors, and pilots, so consistently that researchers treat it as a standard product of the brain under isolation, exhaustion, cold, and threat. Charles Lindbergh, flying the Atlantic alone in 1927, sleepless past the second night, described the fuselage behind him, filling with presences, vaporous forms he could sense and almost converse with, who seemed to advise him on navigation and vanished with the daylight. He withheld the account for a quarter century, publishing it only in his Pulitzer-winning memoir, for exactly the reason this list keeps encountering. He knew how it would sound. Mountaineers above 8,000 meters report the phantom companion so routinely that expedition literature treats it almost as a landmark of altitude, one more thing that appears near the summit, along with the ice and the narrowed sky. The experience has a consistent grammar everywhere it occurs. A sensed companion, usually protective, just outside the field of vision, conjured by a mind at the end of its resources, most likely from the same machinery that lets you feel someone standing behind you. The third man is not a ghost story. It is a documented, repeatable feature of human neurology under extremity, and it tells you what kind of being the strained brain defaults to inventing. A presence, human-like, calm, benevolent, watching. Which is to say, the brain's stock phantom, produced at altitude and at sea for as long as there have been humans in extremity, is already most of the way to an angel. The tabloid did not invent something alien to the human mind. It plagiarized the mind's own oldest hallucination and gave it wings and a Soviet address. That is the real disturbance at the bottom of this entry, and it is worth stating plainly. In the calm this channel owes you. The angels of Salyut 7 never flew. But the machinery that could make a lone, exhausted human being in orbit see something like them is standard equipment, installed in every skull on this planet and every skull we will ever send off it. It requires no malfunction of character, no weakness, no madness, only the right subtraction of sleep, air, and company from an otherwise excellent brain. The cosmonauts of Salyut 7 deserve to be remembered for their 237 days, not for a checkout aisle invention. And the legend deserves to be remembered too, but correctly, as a demonstration that a story that never happened, if it is shaped exactly like the mind's own native phantoms, can outlive and out-travel every true report in the archive. The fabricated angels are now better known than the real red light over Skylab, the real knocking on Shenzhou, the real music behind the moon. Falsehood did not have to defeat the truth. It only had to be more shaped like what we already expected to see. One more word, before we leave the angels, on behalf of the people who believe such stories, because this channel does not hold its listeners in contempt and will not start now. The appetite the legend feeds is not foolishness. It is the entirely reasonable intuition, confirmed 5 times already on this very list, that the environment above the sky produces experiences the ground cannot imagine, and that institutions have not always been honest or curious about what their flyers report. Pilots really were dismissed for 60 years about sprites. Glenn really was whispered about. The lesson of Salyut 7 is not that strange reports from orbit deserve contempt. It is the opposite. The true reports deserve such care, such patient checking and honest labeling, precisely because fabrications exist and flourish. Skepticism, done properly, is not the enemy of wonder. It is wonder's quality control. There is, however, one place in spaceflight where no legend is required, where the perceptions are real, shared, and on the record, and where nearly every voyager who has been there reports the same enveloping presence, not a figure, but a thing without edges, waiting on the other side of the visor. It arrives on schedule, 16 times a day. The crews who work inside it describe it in language they visibly struggle to keep professional. We come to the black of the night side. Number 2. The black of the night side. Every entry on this list so far has been an exception. One crew, one flight, one strange occurrence. This entry is the opposite. It is the rule. It happens on schedule, 16 times a day, to every spacecraft in low Earth orbit, and it has been reported in strikingly convergent language by spacewalkers across 60 years, 2 rival programs, and every generation of vehicle. Roughly half of every 90-minute orbit is spent on the day side of the Earth. The other half, about 45 minutes at a stretch, is spent in the planet's shadow, in orbital night. Inside the spacecraft, night passes are a matter of window shutters and work lights. The transition is also violently physical, in ways the suit is engineered to hide from you. In direct orbital sunlight, the outer surfaces of a spacesuit heat toward 250 degrees Fahrenheit, hot enough to bake. In shadow, they plunge toward 250 below, cold enough to make metals brittle, and the crossing between those worlds takes seconds. The suit's 14 layers, its heaters, its water-cooled underwear, hold the human inside at room temperature across a 500-degree swing, and a spacewalker feels the change mostly as light and as a faint new conversation among the suit's systems. But outside, on a spacewalk, when the station crosses the terminator and the sun is subtracted without warning or twilight, the environment transforms into something no training pool can fully rehearse, and the astronauts who have worked through it keep reaching, decade after decade, for the same inadequate words. The black. Not darkness, they insist, as though correcting an error the listener has not yet made. Something with more substance than darkness. A black that appears closer than the stars embedded in it. A black, more than one has said, like velvet, which is a strange comparison to hear from a test pilot, because velvet is a texture, and texture is precisely what an absence should not have. To understand what they are describing, start with what space looks like out there when the sun is up, because it is not what most people assume. In full daylight, a spacewalking astronaut sees no stars at all. The sun, unfiltered by any atmosphere, is a brutal white lamp. The station gleams, the Earth below is an enormous glowing floor, and the astronaut's pupils, stopped down against all that light, cannot gather the faint light of stars. The day sky of orbit is therefore a black, more absolute than any night sky you have ever seen, and completely empty. Astronauts describe working against a backdrop of pure nothing, a matte black ceiling with not one point of reference in it. Then the Terminator comes. The sun sets in seconds, sliced off by the edge of the world, and the temperature of the suit's sunlit surfaces begins to fall at once, and the spacewalker is in night. Now the pupils open, and the sky that was empty fills. Stars come out by the thousand, and they do not twinkle, because twinkling is a gift of the atmosphere, and there is no atmosphere here. They burn with a fixed, unblinking steadiness that several astronauts have described as the single most alien sight of the entire experience. Familiar constellations rendered strange by their sheer, motionless clarity. The Gal Bay, the Milky Way, appears not as a faint smudge, but as a structured river of light with visible dark lanes. And below, where the Earth was, there is now, if the pass crosses open ocean on a moonless stretch, nothing whatsoever. No lights, no horizon, no floor. The planet becomes a hole in the stars, a volume of pure absence directly beneath the boots, and the only evidence that the world still exists is the missing starlight where it hangs. Stand there for a moment, present tense, in the boots. You are halfway through a 7-hour spacewalk, and the Terminator takes the sun mid-task. Your gloves keep working, because the work is lit by the lamps on your helmet. A warm little pool of aluminum and tether hooks a meter wide, and everything beyond the pool is gone. The station is a suggestion now, a few glinting edges where your light falls off. 100 meters of home you can no longer see. You finish the bolt. You pause, as you are trained not to, but everyone does, and you look up. The stars are out, thousands of them, fixed and unwinking, harder and cleaner than any desert sky, and between you and them there is nothing, and the nothing is the thing. It does not read as distance. It reads as proximity, a black so present it seems near, as though it had a surface just past your visor, as though you could touch it if you let go of the rail. Below your boots, where a planet ought to be, there is a starless region, a shape of pure absence, and your inner ear, silent for hours, chooses this moment to file its report. You are falling. You are falling, it says, into that. Your glove is on the rail. You confirm it by looking, because feeling is not enough just now. In 40 minutes, the sun will detonate over the far edge of the world and repaint everything back into existence. You go back to the bolts. It is in that configuration, working by helmet lamps on a structure 100 meters long over an invisible planet inside an unblinking sky, that the human vestibular system begins to offer its opinions. On Earth, your inner ear and your eyes collaborate to tell you which way is down and whether you are falling. In orbit, the inner ear has no gravity vector to report, and on the night side, the eyes lose their references too. The brain, starved of data but unwilling to stay silent, begins to improvise, and its favorite improvisation, reported by spacewalker after spacewalker, is the sensation of falling, which is, of course, technically accurate. An orbiting astronaut is falling perpetually around the planet at more than 17,000 miles per hour. The brain is not wrong. It is simply telling a truth the mission requires it to suppress. Astronauts describe the nightside moment when the mind quietly insists that the blackness below is down, that down is very far, and that the only thing preventing the fall is one gloved hand on an aluminum rail. The hand grips harder. Crews call it perfectly normal. The heart rate telemetry, which the ground reads in real time, records what normal costs. And the hardware acknowledges the stakes. Every spacewalker on the American side flies wearing a small jetpack called Safer, a last resort maneuvering unit with a hand controller, carried for exactly one scenario, the one in which the tethers have failed, the gloved hand has come off the rail, and the station is receding into the black. It has never been needed in a real emergency. It is checked before every excursion anyway, because the darkness below the boots is not a metaphor to the people who plan these outings. It is a destination, one slip wide, and the jetpack is the only ticket home. The history of spacewalking bookends this experience with two stories that belong here, both entirely real and both instructive about what the black extracts from even the best. The first spacewalk in history, Alexei Leonov's, in March of 1965, lasted about 10 minutes outside the Voskhod 2 spacecraft, and Leonov spent his life afterward describing the silence of it, a quiet so total that he could hear his own heartbeat, his own breathing, the blood in his own body, the only three sounds in his universe. The poetry ended there because his suit, pressurized against vacuum, ballooned and stiffened until his hands pulled out of his gloves and he could no longer fit through the airlock. Leonov, calmly and without telling the ground, bled air out of his own suit, deliberately lowering his pressure toward dangerous thresholds until the suit softened enough for him to force his way inside, head first, against regulations, soaked in sweat, and half again past his exertion limits. The first human being to float free in space came within a few decisions of being the first to remain there. And 1 year later, in June of 1966, Gene Cernan, the same Cernan who would later listen to music behind the moon, flew the second American spacewalk on Gemini 9, and it has entered history under the name he gave it, the Spacewalk from Hell. The planners had assigned him a workload built on a catastrophic underestimate of how hard it is to move a pressurized suit with no handholds, no footholds, and nothing to push against. Every turn of a wrist cost him. His heart rate climbed toward 180 beats per minute, a sprinting heart sustained for the better part of 2 hours. The exertion overwhelmed the suit's cooling, and his visor fogged from within, blinding him, so that he worked by feel, gasping, over the invisible earth, while his crewmate coaxed him back toward the hatch. He lost several pounds of body weight in sweat in those 2 hours. NASA rewrote its entire approach to spacewalk training because of what that black afternoon taught them, which is why the pool exists in Houston, where every spacewalk since has been rehearsed underwater, and why no one has repeated Cernan's afternoon since. And even with all of it rehearsed, the black finds its moments. In 2001, on his first spacewalk outside the new International Space Station, Chris Hadfield, who would later command the station, was working through his tasks when his left eye began to sting, then blur, then squeeze shut entirely. A droplet of the anti-fog solution used to polish the inside of his visor had lifted free and found his eye. On Earth, a stinging eye waters, and the tear falls, and you blink and carry on. In weightlessness, tears do not fall. They pool. The contaminated tear film sat on his eye, grew, and then, bridging across the top of his nose, in the way liquids move when nothing pulls them down, spread into his right eye as well. And so, hanging on the outside of the space station, in the black, Chris Hadfield went completely blind. He could hear his own breathing, feel the rail in his glove, and see nothing at all. He reported it with the studied calm of his profession, and the ground talked him through it. Unable to rub his eyes through a helmet, he eventually cracked open a purge valve and let the escaping air dry the tears until, minutes later, his vision cleared enough to finish the job, which he did. He tells the story now as a lesson in preparation and composure, and it is. It is also, for our purposes, the purest distillation of this entry. The environment out there is so absolute that the distance between a routine afternoon and total helpless blackness can be one floating droplet, smaller than a pea. The night side offers consolations, it should be said, and the astronauts collect them with the same seriousness they give the hazards. Auroras, seen from orbit, do not hang overhead as they do from the ground. They writhe below and beside the spacecraft, green and red curtains of light, hundreds of miles tall, and spacewalkers have described the frank strangeness of working above the northern lights, watching them ripple beneath their boots like weather. Cities cross the night as galaxies of amber. Lightning storms strobe inside distant cloud, illuminating whole thunderheads from within, the same storms whose upward fireworks this list has already visited. There is a thin band of green-gold light, airglow, that sleeves the whole planet's night edge, the atmosphere faintly shining by its own chemistry, visible only from out there. Some astronauts caught the black on purpose. There are accounts of spacewalkers and window watchers deliberately dousing every light they control, waiting out the minutes of dark adaptation and letting the full night sky assemble itself, an act of intentional exposure to the very thing this entry is about, performed for the reward on the other side of the vertigo. The galaxy, seen properly, once, with nothing in the way. Crews on night passes fall silent over the radio, and the flight surgeons reading their telemetry can watch the heart rates settle. The black frightens the body and feeds something else, and every account holds both truths without apology. Set the incidents aside, though, because the heart of number 2 is not any single emergency. It is the ordinary experience, the one every spacewalker gets, of pausing in the night pass, lamps off, or eyes lifted from the worksite, and confronting the thing itself. The reports converge on a paradox. The black is felt as a presence rather than an absence. It appears to have depth without distance, nearness without location. Astronauts, the most operationally minded humans our species produces, come home and use the vocabulary of confrontation. Staring into it staring back, refusing to look at it too long, keeping the eyes on the metal. There is nothing mystical in this, and none of them claims there is. It is a human visual system, evolved under a lit sky above a flawed world, being shown, for the first time in its evolutionary history, a truly unbounded volume with nothing in it, and reporting that experience in the only language available. You have stood at the edge of the Grand Canyon, perhaps, or at a cliff over dark water at night, and felt your body announce the drop before any thought formed. A nightside spacewalk is that announcement, without the cliff, without the water, without the bottom, in every direction at once, held at bay by one hand on a rail and a visor's width of acrylic. The astronauts go back out anyway, 16 nights a day. It may be the most routinely repeated act of courage our species performs. It is customary, when describing what astronauts see, to reach for the overview effect. The documented shift in perspective, reported by so many who have looked back at the whole Earth, the borderless blue marble, the felt unity of everything below. It is real, and it changes people, and it is the daylight half of a pair. The black of the night side is its shadow twin, less quoted in commencement speeches, reported just as consistently. The same window serves both. Face the planet, and the mind is handed everything. Home, wholeness, every human who ever lived in one glance. Face away, into the black, and the mind is handed the context. How small the everything is, and how much of the rest there is, and how little of it is lit. Most astronauts describe encountering both, sometimes in the same hour, and the honest ones decline to rank them. The Earth teaches you what you are part of. The black teaches you what that part is suspended in. A complete education out there requires both windows, which may be why the crews keep going back outside, 16 nights a day, into the one classroom no simulator has ever reproduced. The label for number 2, universal and universally understated by the people who know it best. Because here is the strangest thing about the black outside the visor. For all its size, it is survivable by the simple act of coming back inside. Close the hatch, and it is gone. The final entry on this countdown offers no such mercy. It waits until the hatch is closed. It waits until the work is done, the suit is stowed, the cabin lights are off, and the astronaut, wrapped in a sleeping bag, finally closes their eyes. That is when it appears. It has appeared to moon crews and station crews, to Americans and Russians, and nearly everyone else who has flown far enough for over 50 years. It cannot be photographed, because it never enters any camera. It happens inside the eye itself, and it is not an illusion. It is the most disturbing thing astronauts have ever seen, precisely because it is real, it is physical, and there is no direction to look that makes it go away. We come, at last, to number 1. Number 1. The lights astronauts see with their eyes closed. In July of 1969, on the way to the moon, Buzz Aldrin settled in to sleep. The cabin of Apollo 11 was darkened for the rest period, the spacecraft coasting through the 250,000-mile gulf between the Earth and its destination. And Aldrin closed his eyes. And there, in the private darkness behind his own eyelids, he saw light. A flash, small and white, like a spark, or like the pop of a camera bulb seen through closed lids. Then, some time later, another. Some came as points. Some came as thin streaks that crossed his closed-eye darkness from one side to the other, as though something very small and very fast had traversed the inside of his head, drawing a line of light behind it. He watched this for a while, in silence, doing the arithmetic every astronaut on this list has had to do, the arithmetic of whether to say something. Then he asked Neil Armstrong. And Armstrong said he had been seeing them too. Stay in that cabin, present tense, for 1 more minute, because this is the last scene of the countdown and it has earned its full weight. The spacecraft is coasting, engines silent. The only sounds, the ventilation, and the small taps and shifts of 2 other men settling towards sleep. You are strapped loosely so you will not drift. You close your eyes, and the darkness behind your lids is the same darkness you have known every night of your life. The one private room every human being owns. And then, without sensation, without sound, without warning, there is a line of light across it. Thin, white, drawn left to right in an instant, like a meteor that has somehow fallen inside your own head. You open your eyes. The dim cabin, the instrument glow. Nothing. You close them. The dark holds for a while, being ordinary. Then a point of light blooms and dies, off-center, like a single distant flashbulb. You are not asleep. You are not dreaming. You are the most tested man of a tested generation, on the most examined voyage in history, and something is producing light in a place where light has no way to be. The ventilators breathe. Behind your eyelids, at its own pace, the universe continues to arrive. Neither man knew it in that moment, but they had just joined one of the most exclusive and least advertised clubs in human experience, and they had discovered the phenomenon that sits at the top of this countdown. In the debriefs after the mission, the flashes were reported and taken seriously, and it is worth appreciating what taken seriously meant in that institution, in that decade. Nobody suggested the crew of the first moon landing had imagined things. The Fireflies' lesson had been learned, and besides, 2 independent witnesses in one cabin is corroboration by any standard. Instead, the agency did what it did best and turned the mystery into a protocol. On Apollo 12 and the missions after, crews were asked to watch for the phenomenon deliberately, and dedicated observation sessions were added to flight plans. An astronaut with eyes closed or the cabin darkened, sometimes wearing a blindfold to standardize the dark, calling out each event as it came, mark, describing its shape and direction, while a crewmate logged the time against the mission clock. Picture that scene honestly. Men riding to the moon, blindfolded on purpose, narrating sparks that only they could see, into a tape recorder, for science. It remains one of the strangest routine activities ever added to a flight plan, and the crews performed it with complete professionalism, because by then everyone understood that the sparks were data. The flashes came, on average, about once every 3 minutes during the translunar coast. They came in a small taxonomy of forms that every deep space crew learned. Spots, like single stars igniting and dying in an instant. Streaks, lines drawn fast across the visual field, and occasionally what the reports call clouds, a diffuse, brief glow, as though a puff of luminous smoke had bloomed and vanished behind the eyes. They appeared whether the eyes were open or closed, but the darkness made them obvious, and so it was at bedtime, in the quiet minutes before sleep in a darkened spacecraft on the way to the moon, that most of them were seen. Some astronauts found them interesting. Some found them company. And more than one, over the decades since, has admitted to lying in the dark, being kept awake by them, watching involuntary fireworks against the inside of their own eyelids, and understanding, with a clarity no briefing could soften, exactly what each flash was. Because the explanation was worked out within a few years, and the explanation is the reason this phenomenon stands at number 1, above every light and object and sound in this countdown. The flashes are cosmic rays. They are atomic nuclei, the stripped cores of atoms, most of them born in supernova explosions elsewhere in the galaxy, accelerated by the shock fronts of those dying stars to speeds approaching the speed of light, and sent wandering across the galaxy for millions of years. Space is full of them, everywhere, always. A thin, permanent rain of relativistic matter falling in all directions. On the surface of the Earth, you are shielded from nearly all of it. The planet's magnetic field deflects a great share, and the atmosphere above your head, equivalent in stopping power to a slab of water 10 meters thick, absorbs and shatters most of what gets through. An astronaut beyond the atmosphere has surrendered that roof. The spacecraft's hull stops some of the rain, but the heaviest, fastest nuclei, iron cores and their kin moving at nearly the speed of light, pass through aluminum, the way a rifle round passes through morning fog. They pass through the hull. They pass through the sleeping bag, and the skull, and everything the skull contains. And every so often, one of them passes through an eye. When it does, the eye reports it, because the eye is a light detector and a heavy charged particle crossing it deposits energy in exactly the way the retina is built to notice. The particle ionizes a track through the retinal tissue, triggering the photoreceptors along its path as though light had struck them. And in some events, physicists believe there is real light involved as well, generated inside the eyeball itself. A particle traveling faster than light travels through water, which is permitted, since light slows in water, produces a shock wave of bluish light called Cherenkov radiation, the same blue glow that surrounds the submerged cores of nuclear reactors. The vitreous humor of the human eye is mostly water. A sufficiently fast nucleus crossing it generates a tiny Cherenkov flash inside the eye, a reactor glow in miniature, contained within a sphere the size of a grape, seen by an audience of exactly one from the inside. Either way, ionization track or Cherenkov cone, or both, the perceived result is the same. A spark, a streak, a bloom of light that never existed outside the observer's own head, and yet was caused by something entirely physically real. The flash is not light arriving at the eye. The flash is the eye being struck. Pause on the scale of the messenger, because the numbers deserve their moment. A single iron nucleus arriving at cosmic ray energies carries, packed into one atomic core, roughly the kinetic punch of a thrown pebble, which sounds small until you place it against the fact that the object delivering it is 100 trillion times narrower than the pebble. Matter compressed to that concentration of energy does not interact with the body the way light does, or heat, or anything in ordinary experience. It simply transits, shedding a thin line of disruption through whatever it crosses, bone and instrument and eye alike. The particles seen by Apollo crews had typically been traveling for a few million years before arriving, launched by supernova remnants whose light finished passing the Earth before humans existed. Their density in space is almost nothing, a handful crossing a given eye per hour of exposure. But an eye is a small target, and a flight is long, and once every few minutes, on average, geometry completed the appointment. This explanation was not left as a theory. It was tested, and the test deserves description, because it is one of the strangest experiments in the history of medicine. On the final Apollo missions, Apollo 16 and 17, a crew member spent part of the translunar coast wearing a device called AlfMed, a helmet, heavy and blind, lined on all sides with plates of particle track emulsion, a photographic material in which a passing cosmic ray leaves a permanent microscopic scar. The astronaut wore the helmet in darkness, calling out each flash as it happened, its time, its shape, its position in the visual field, while the emulsion silently recorded every actual particle that crossed the helmet's volume. Afterward, on the ground, the plates were developed and the tracks were measured, and the two records were laid against each other. They matched. Flash after reported flash lined up, in time and in geometry, with the etched track of a real heavy nucleus passing through the plates, through the helmet's interior, through the region occupied by the astronaut's head, on a line through the eye that had reported it. There is something almost ceremonial about that dataset. A human perception, the most private event there is, a spark seen behind closed eyes, confirmed line by line against physical scars in a photographic plate. The lights were real. The lights had always been real. The 1 in 5 who never see the flashes deserve their footnote, because the variation is itself informative. Perception of the events depends on the sensitivity of an individual retina, on where in the eye the particle happens to cross, on dark adaptation, on attention, and on the simple fact that a flash at the edge of vision during a busy shift goes unremarked, where the same flash at bedtime becomes an event. Some astronauts report them nightly. Some needed to be told what their crewmates were talking about. The particles, of course, are perfectly democratic. The dosimetry shows every head aboard receiving its share. The flashes are not a report of who is being hit. everyone is being hit. They are a report of whose wiring happens to mention it. The observations did not end with Apollo. Skylab crews logged flash sessions on their long stays, and shuttle crews carried the observations on. Aboard the Mir station, through the 1990s, a series of detectors called Salyut did the same work with silicon sensors, correlating cosmonauts' reported flashes with measured particle crossings. Aboard the International Space Station, an experiment called Altair, beginning in 2006, went further still, fitting astronauts with a helmet of silicon particle telescopes that tracked nuclei through the head in 3 dimensions while recording the brain's electrical activity, watching, in effect, the galaxy interact with a living human nervous system in real time. The census across all these decades is consistent. Roughly 80% of astronauts perceive the flashes, most within their first day or two off the Earth. About 1 in 5, for reasons involving the ordinary variety of human retinas and attention, never notice them at all. In low Earth orbit, they come less frequently than on the way to the Moon, because the planet still blocks half the sky and its magnetic field still turns much of the rain away. But the station's orbit passes, several times a day, through a region over the South Atlantic, where the Earth's inner radiation belt sags closest to the surface, the South Atlantic anomaly, and crews report the flashes arriving there in flurries, the count climbing for the minutes of the crossing, the inside of the eyelids briefly busy, and then settling again as the station flies out of the weather. It is, quite literally, weather. The crews experience it as a passing storm, except that this storm precipitates through the hull and through them. Honesty requires the wider ledger, stated calmly, because the flashes are the visible edge of something the space agencies take with complete seriousness. The same particle rain that sparks the retina deposits its thin lines of disruption through every tissue, not only the one wired to notice, and the accumulated dose is among the fundamental constraints on how far and how long humans can fly. Studies of the Apollo generation have examined their eyes and health across decades. Astronaut radiation exposure is tracked over entire careers, with lifetime limits that can and do ground veterans. And the design of any future Mars vehicle is, to a first approximation, an argument about shielding, because a multi-year voyage beyond the Earth's magnetic shelter means standing in the rain for the duration. None of this is catastrophe. Doses are managed, limits are conservative, and every flyer accepts the arithmetic knowingly. But it reframes the flashes properly. They are not a curiosity at the edge of the mission. They are the mission's oldest constraint, introducing itself personally, one spark at a time, to each new traveler. Sit with what that means for the person inside it, because this is the heart of number 1, and the reason it outranks every entry above it. Every other case in this countdown could, at least in principle, be avoided. Do not look out the window, and you will not see the fireflies or the red light. Turn off the radio, and the moon will keep its music. Even the black of the night side ends at the hatch. The flashes cannot be declined. They happen on essentially every flight, to nearly every flyer, in the one refuge no environment had ever before breached, behind closed eyes, in the dark, at the edge of sleep. And they are not a trick of the tired mind, which is what makes this entry the inversion of the Salyut 7 angels. The angels were a perception with no reality beneath it. The flashes are reality arriving in person, each one a genuine physical object. A nucleus forged in a star that died before the sun was born, accelerated by that star's death, aimed by chance across millions of years and trillions of miles, ending its journey in the wet dark of a particular human eye on a particular Tuesday, announced by a spark. The astronaut who sees it is not observing the universe through an instrument. The astronaut has become the instrument. The detector is the eye, the readout is the flash, the observatory is a sleeping bag strapped to a wall, and the experiment runs all night, every night, whether or not anyone consents to take part. Slow down here, because this is the floor of the whole countdown, the place every entry has been descending toward, and it deserves to be felt at full weight and at low volume. Somewhere above your head tonight, an astronaut is strapped into a sleeping bag with their eyes closed, and inside that closed dark, a star that died before the sun existed is finishing a delivery. That is not a metaphor, and it is not a poetic reading of the physics. It is the literal chain of custody, checkable link by link. A massive star ended. Its shockwave took an atomic nucleus and spent the energy of a dying sun accelerating it. The nucleus crossed some fraction of the galaxy, while the Earth went from single cells to cities, and the journey's final inch was the width of a human eye, announced with a spark to the only consciousness that will ever know it happened. The astronaut blinks, notes it, and goes to sleep. There is no other place in human experience where the distance between the largest things and the most intimate things collapses so completely, and the people who live at that collapse point report, almost unanimously, that you get used to it, which may be the most quietly astonishing sentence in all of space medicine. Do you remember the Fireflies? From the top of this list, 3 hours ago, John Glenn, at his first orbital sunrise, watching a swarm of soft lights drift past the window, lights that turned out to be his own spacecraft, shedding its frost. The ship's breath made visible. The countdown ends where it began, with small drifting lights, and with the distance between the two tellings measuring everything this list has descended through. The Fireflies were outside the glass, and they were the ship. These last lights are inside the eye, and they are the galaxy. Between those two sentences lies the whole inward arc, from particles at the window to objects in the sky, to voices in the radio, to knocks in the wall, to phantoms in the mind, and finally to this, the universe itself, crossing the last boundary there is, the one between the world and the witness. 60 years of spaceflight, looking outward for the strange thing. And the strangest thing found so far is that, far enough from home, the sky does not stay on its side of your eyes. And yet, notice the temperature of the ending, because it is not cold. The astronauts themselves, almost universally, do not describe the flashes with dread. They describe them the way this whole list, at its best, has taught us to hold the unexplained and the barely bearable alike, with attention, with honesty, and eventually with something close to affection. Buzz Aldrin, asked about them across the decades, has recounted the flashes with evident fondness, one more strange gift of the strangest week of his life. Astronauts on the station today, floating in their sleeping bags through the South Atlantic anomaly, watch the sparks arrive and drift off to sleep inside them, guarded by engineers who count every particle in the most closely monitored bedrooms our species maintains. The rain was always falling. It fell on the dinosaurs, and it falls on you, thinned to almost nothing by 10 meters of air, a stray survivor still occasionally threading the roof, the walls, the dark, entirely unfelt. The astronauts are simply the first of us to sleep out from under the shelter, and to see, with their own closed eyes, what the night is actually made of. And you, listener, are part of this entry too, in a way you were part of no other on the list, which is the last thing to know before the countdown closes. The rain does not stop at the atmosphere, it is merely filtered. A small fraction of cosmic ray products reaches the ground, passes through ceilings and beds and sleepers, every night, everywhere, and has done so for the whole history of life. Once in a great while, one crosses a human retina at the correct angle, and people with no connection to spaceflight, lying in dark rooms, see an unexplained spark and think nothing of it, and are almost never told what it likely was. The astronauts do not see a different universe. They see this one, with the shielding reduced, the true sky brought close, the arithmetic of 10 meters of air stripped down to a hull's width of aluminum. What waits above the atmosphere is not an alien phenomenon. It is the ordinary night, undiluted. So the list ends inside the eye of the witness, which is where, in fairness, every sighting on it always lived. 10 cases, 10 labels, and one shape to remember them by. The strangeness of space is real, it is patient, and it moves inward, from the window, through the wall, to the watcher, growing more honest the closer it comes. The people who saw these things reported them carefully, doubted themselves first, told the truth anyway, and left the lights on for whoever came next. That is as much comfort as the dark has ever offered, and it has always been enough. Sleep well, and good night.